my throat. Good morning, everyone from Chicago, where we've got about 18 degrees Fahrenheit, clouds, and wishing that we were either in Dubai, Florida, Abu Dhabi, Doha, or any place else. First thing I'd like to ask is if people can hear me. So if you look at your control panel on your webinar toolbox, there's a hand. If you raise your hand quickly, like now, then I can tell whether or not you're able to hear me. That's a good thing. For those of you that grew up in the 60s, you can think of this like Romper Room. When we were kids, the Romper Room TV show had a lady that looked in a mirror and said she could see every one of you. While I can't see you personally, I can see the names and your hands going up. So it's almost like although I'm sitting in Chicago and my friends are sitting everywhere in the world, I can still see you and talk to you, which is really quite a cool thing that the technology has done for us. Those of you who say that that maybe the volume is a little low, try the volume on your computer. Crank it up as much as you can without it getting distorted. Second thing I want to do is make sure that the video is working. So I'm moving the screen. If you can see the screen moving, I need you to do the same thing. Kind of take down your hand and then put it back up. And if you can't see the screen moving, then I suggest that you sign off and then sign back on because it might be a glitch with the software and the programming from GoToWebinar. We're really pleased to be able to offer this webinar and a series of them. We're going to do about a dozen of them this year, once a month. Some will be 2 hours, some will be 1 hour, and you'll be able to get additional CEU credits, learning units, I guess I should say, if you talk to both FM approvals, underwriters laboratories, international accreditation services, they all will mention that learning units, the hours, are what you get credit for. So what we do is we give out certificates of attendance, and it takes a few weeks to get them to you because we get hundreds of people on the webinars, and we do the old-fashioned way, manually make a PDF that has the learning unit and the hours on it. We check the software that says how long you were on the call, and then we're able to verify to the various organizations, whether it's AIA, ALA, or others, that yes, you were on the call. Currently, we are applying for AIA CES credits. We're applying for a preferred provider with the International Code Council and others. So the next webinar, maybe even this one, I don't know if we'll be able to backdate, but you'll be able to get accredited education from some of those other organizations. So certificates will be issued in the next couple of weeks. If you don't get one in a month, hit us on the email at bill@fcia.org or linda@fcia.org. A couple other housekeeping items. This program will go for about 2 hours. We'll also post this webinar up at the FCIA website, fcia.org. On the right-hand side over here, where my cursor is moving now, you'll see the hot news. And under the hot news, we'll put a link to the presentation in a PDF version so you can download it. We're undecided yet whether to offer the video portion, not the video, the audio portion with it. I am recording this session so that it might be available to members, likely will be available to members in the members only section as a benefit that you can use to play for your employees at any time during your work year. So a couple other details. The question and answer session, the question and answers, I have a control panel on my computer that shows me the questions as you type them in. So when you type them in, for instance, I made the comment about the PowerPoint presentation because somebody asked me the question, are you going to provide it? Yes, I am. Second thing was somebody asked if I can put our contact info back up again. So I can see that question that came in already very quickly and able to keep an eye on it. If you have a question, please feel free to either type it in, and I'll try to catch it. If you can type it in while I'm still on the slide, I'll try to catch the question while I'm on the slide. The other way to ask a question, the best way to ask a question while I'm delivering the presentation is through the questions, typing them in. At the end of the program, at about an hour and a half, hour and 45 minutes, I'll open up the microphone for verbal questions so that if you've got a question, you can ask it, and we can have some back and forth dialogue with the various attendees on the call. It's our way to make this a great industry session that shares information and then seeks clarifications from the group, and maybe you understood something a certain way, and it gives us a chance to have an open chat about that as well. I see a couple of questions, but I'm guessing those are just up early. So again, if you have a question, right now type it in, and if later, we'll open up the microphone and be able to have a conversation. A couple other housekeeping items. If you have multiple people at your location, I won't be able to know, we won't be able to know who is at that location. So if you've got 10 people sitting in your conference room and you want certificates for everyone, I need a list of those names sent to bill@fcia.org or to info@fcia.org. If you're alone, great, no problem. If you've got multiple people, let us know. The various entities that take these learning units and give you credit for them, they'll have to trust you, I guess, to make sure that you've provided the names, the right people, all that kind of thing. So we appreciate you taking some time to visit with the Firestop Contractors International Association about the design, installation, inspection, and management of fire stopping and effective compartmentation. This program has been expanded and is offered to the American Society of Healthcare Engineers in a day-and-a-half session. The barrier management symposiums that we work together with Underwriters Laboratories, the American Society of Healthcare Engineers, the Joint Commission, and FCIA, we present those symposiums around the country at various locations. The next one's coming up the month of April 14 and 15 in Rochester, Minnesota. We have about 3 others that will be taking place throughout the year, probably after April, serving other parts of the country. We had 3 successful symposiums last year with between 100 and 200 people attending each one. And the symposiums, barrier management symposiums, cover more than just fire stopping. They cover fire-rated glazing, fire resistance-rated doors from the swinging door perspective and their builder's hardware, fire-rated dampers, smoke dampers, the fire-rated glazing, fire stopping, gypsum fire-rated walls, concrete block walls. Bill Koffel does a great session on barriers and what those are. Rich Walke from Underwriters Laboratories delivers a fabulous session on the testing for all the different types of fire resistance rated materials that become systems after they're tested and listed for the specific application. Keep an eye on that website, FCIA.org, and we'll post the barrier management symposiums so that you'll know when they are. They're open to healthcare engineers and others, but most importantly, we request that you join the FCIA. Why? Because we're the active association that's sponsoring these and putting them on. I had a question come up about the nuclear industry and whether this program is applicable applicable to the nuclear industry. Fire resistance rated construction is used throughout that nuclear power industry. There are some different rules for fire stopping in the companies that operate in that environment. The rules are governed under 10 CFR 50, Part 21, which is a code of federal regulations, different than is required in the normal operation of a commercial office building and industrial facility. Those structures, though, still have fire resistance rated construction to mess with. The concepts are the same for the testing, for the suitability for use. And we'll get into some of that as we go through this. Next question that came up was, do we have to attend the question and answer session of the program to get the 2-hour credit? Only way you get 2 hours worth of credit is if you're on this call for 2 hours. And we'll be able to see that by when you sign on and when you sign off. We advise you stay on for that period of time. So thank you for the questions. So what's the objectives of this program? Cover the DIIM. What are the standards for fire stopping? What are the standards for installation, contractor qualifications? What are the inspection requirements? And then what's the maintenance and management? That DIIM is something that we as an association have been talking to the other fire resistance rated construction industries about to make sure that their reliability of the installed systems works when called upon by fire or smoke. That's really the critical point. If we've spent all this money testing fire stopping, we meaning the manufacturers, and any of these manufacturers, very respectable companies, honorable companies, have invested billions of dollars in testing at FM approvals, Underwriters Laboratories, Intertech Laboratories, Southwest Research, to determine the suitability for use of these products in specific applications. They also spend lots of money on their own quality processes, mixing and formulating the materials for use. Then the materials get sold to a distributor, to a hardware store, into a contractor's hand, into an individual worker's hand, and then what happens? What we're trying to address with the DIIM strategy is make sure that the amount of time and testing that was put forth, make sure that that same care goes all the way through the process, to the contractor that's installing, to the contractor's personnel that's also got their hands on the material, to the special inspection agency that's required by the 2012 International Building Code, all the way to the people that are maintaining, so that that systems philosophy flies all the way through. We've got a code proposal that's going in this cycle, went in last night for the International Code Council, to try to help with that, to drain the swamp on some of that problem. You'll see about why as we go through the program. But the big thing is that if we know the system number, Firestop system number, then we know what materials were used to make that system and what the recipe was, what the angular space size, how big it was, what shape it was. We know all of those characteristics by the system. Without the system number, we have no idea what was installed in that area and what should be in that area. We then have to go paging through thousands of systems to figure it out. One simple thing gets it done. Finding a way to have the system number at the job site on the penetrating item or hanging from it or on the wall, on the barrier, helps us figure that out. We'll get into that later on. That's another debate for another day, and it will be interesting to see how it all comes together. So what we want to do is focus on that DIIM, focus on the specification, and set the base for our year's program throughout. And what we're going to do throughout the year is take this program and take pieces of it and cover it in great detail. Engineering judgments is something that comes up frequently as a question. We're going to spend a whole hour on it sometime along the way. And then there's all kinds of other topics that we'll go through as well. We've got some questions that come up. I'm going to cover these later on when we get into it and go from there. So let's keep moving. First thing is, who's FCIA? I'm only going to spend a couple seconds on this. Reason why is if I didn't do a quick plug for FCIA, I wouldn't do my job. As a trade association, we believe in total fire protection, and effective compartmentation is part of that. We believe in sprinklers. We believe in alarms. We believe in occupant education. We believe that a fire alarm, when it goes off, we got to get out of the building. We even do that here at the office. There's fire alarms once every so often here in our office building. Our staff thinks I'm a bit nuts, but I'm the first guy that throws a laptop over the shoulder, throws a wallet in the pocket, and I start walking for the door and start saying to people, grab your stuff, we're out of here. We don't care if it's a false alarm or not, we're out of here. Total fire protection and effective compartmentation as a part of that. I know where the safe places are to go in the building on the way out, and we hope that the rest of the world learns that too. That's something we should be teaching in the elementary schools. You know, they teach about fire safety and smoke alarms and stop, drop, and roll. How about if there's a fire in your place, find that compartment and find a way to get out of it so that you're saved in a building. Talk a little bit about codes, testing products, and fire stopping for safety. What's the DIIM? It's a specification written by a professional. CCS, Certified Construction Specifier from the CSI. RSW, a registered specification writer from the Construction Specifications Canada, using the suggestions out of the FCIA 07-8400 specification. And we believe that spec should be one section. One section because the requirements are basically the same regardless of whether it's penetrations or joints. Test and listed systems selected from a directory, installed to certain specifications, manufacturer's installation instructions, and the tested and listed system. The tested and listed systems with all the test standards, whether they ASTM, FM, UL, or ULC. Those test standards were developed for a reason by consensus bodies. Professional installation. Fire stopping is a trade just like roofing, electrical, mechanical, plumbing, and others. It needs people that know what they're doing with these materials. They're life safety materials. And these life safety materials need to be installed professionally. These are things that you can put in specifications, the FM and UL programs. You want to learn more about the formats? Visit csinet.org, www.csinet.org. That's the Construction Specifications Institute. Go to Construction Specifications Canada, which is csc-dcc.ca, to learn more about specification and also the qualifications of those specifiers. Inspection is important. Special inspection, the ASTM E2174-2393 standards. The FCIA was the code proponent and dropped these into the International Code Council's International Building Code. It wasn't us, actually. It was the membership of the International Code Council that voted for these things to be part of the code. The International Accreditation Services has an accreditation criteria for those inspection agencies. We'll talk about that as well. There's some very specific language in the code that outlines the qualifications for those individuals and their agencies that they work for. And then maintain and manage the codes both have maintenance requirements and management requirements for life safety items like this. Specifiers, architects, building officials, fire officials. The Life Safety Digest magazine is available free of charge for you. We also give away the Manual of Practice for free to specifiers with design firms, governmental building and fire officials worldwide. We probably send out at least a couple hundred of these a year on PDF for free to the building officials and fire marshals. We know they don't have budgets. This is our way to say, here's a tool that you can use to learn more about our industry. Look for a big announcement in the next couple of months on that one as well. And Life Safety Digest is available for free of charge as well. Those manufacturers on the call, I would hope that maybe you might consider advertising in that magazine. Circulation's about 12,000 with building officials, fire marshals, architects, engineers as the key audience, including fire stop contractors, obviously, but those other audiences are who read Life Safety Digest. What's total fire protection? We mentioned it before. This is what we're after. And one of the things the FCIA has done through our Barrier Management Symposium is start discussions of the fire resistance rated industry, the walls and floors, gypsum industry, concrete industry, and then the features of fire resistance. fire stopping, fire dampers, swinging and rolling fire doors, and fire-rated glazing. The conversation is, how do we make the DIIM work in each one of those industries? Those industries have their own culture, and they have to come up with programs on their own to come up with those things. Some of those industries have done that. For instance, the swinging fire-rated door industry has the Door and Hardware Institute that developed the Fire Door Assembly Inspector Program. It's a very robust school for the individual fire door inspector. There's also a company program they do as well that helps increase the knowledge of those that are looking fire-rated doors. The FCIA has the FM 4991 program, the ASTM E2174-2393 inspections. Fire damper industry, for instance, has a program for only union signatory sheet metal contractors for a increased quality of the installation of fire dampers for the companies. The fire-rated glazing industry, well, the common thing amongst all of these is there's testing that takes place at UL, Intertech, and FM approvals to very rigorous standards to determine suitability for use of these products in the specific applications. But there's more that our industry can do to increase the reliability of the installed system, whether it's the wall, the floor, the damper, the doors, the glazing, or the fire stopping. Fire stopping is working hard to grow the installed reliability through that DIIM model. The other industries are doing the same. So here's what we're going to talk about the next hour and a half. Let's get to it. Fire resistance rated construction is required by code. The NFPA codes, the National Building Code of Canada, the UAE Fire and Life Safety Code, the Abu Dhabi National Building Code, the International Building Code, Fire Code, all have a chapter on fire resistance and smoke-resistant systems that govern fire resistance in buildings, where it is, and how it's accomplished. The international codes have both a new and existing buildings books, if you will. The International Building Code governs new construction. The International Existing Building Code is now a separate code because Chapter 34 was removed from the International Building Code in the 2015 Building Code cycle. So you won't find the Chapter 34 anymore in the International Building Code. That's all moved over to the Existing Building Code, which governs work inside existing buildings. Somebody asked why they keep losing audio. I'm not quite sure. You might have to check your internet connection, and then also if you keep losing it, sign in and sign out, or sign out and then sign back in and see what happens. The codes determine the minimum requirements for fire resistance in buildings. That minimum requirement is just that, minimum. Some building owners and managers build way above code for various reasons. Energy codes, for instance, some of them believe in greater energy efficiency than what the code requires. Some believe that there should be more robustness to buildings. For instance, some of the high-rise buildings in certain jurisdictions, because of the 9/11 disaster, many of the building owners and managers put extra protection in to protect the biggest asset they have. That's the people that generate the income in those buildings through their work day in and day out. They also protect their computer systems, protect their operations in different ways that aren't necessarily publicly available, that only the architect, general contractor, and the building owner manager really know about. No reason why somebody can't build above code. Fire resistance is defined in the codes as time in minutes or hours that materials or assemblies withstood. A fire exposure is determined by tests. Methods are based on tests or the code. When it says by the code, that's referring to the Chapter 7 of the International Building Code, and then also in the NFPA 101 as well as 5000 code, where certain thicknesses of generic materials such as concrete will provide an hourly fire resistance rating based on a long history of testing that was done 100 years ago to determine the thickness of that system. That's used in various locations, especially in old buildings, to identify what the fire resistance rating was in buildings. All you have to do in an old building where you can't find drawings, can't find specifications, Another thing to do is check the back of that building code, existing building code, find the equivalent rating for the type of material that's in it, and then maybe have a fire protection engineer determine what those hourly ratings are. Common function of all of these systems, regardless of the code, is for continuity of that fire resistance rating. Continuity is a concept that floats into the National Building Code of Canada, the Abu Dhabi National Building Code, the NFPA codes, and the I codes. Continuity of fire resistance is what creates the need for fire resistance rated doors, dampers, fire stopping in these fire rated assemblies. Openings and penetrations are protected, and the question is, what's the robustness? How strong are these assemblies, and what else can they withstand? The international codes in certain occupancies have increased the amount of robustness for some of those walls. For instance, in super high-rise buildings, 420 feet and higher, the stairwells and the important shafts have a requirement to take a blast resistance. Check the International Building Code under that occupancy section, and you'll find where it's required to have blast resistance of those stairwells. Why? To resist some terrorist attack, some explosion that might occur in that building. Does that mean only concrete block can be used in those type applications, or concrete? No, it doesn't. Gypsum assemblies can meet that. We watched it through the International Building Code development process in several cycles coming into 2009, where the gypsum industry built walls that could pass the certain resistance on it as well. So what are the various barriers used in construction? A fire barrier, hourly rated, is determined by the International Building Code. Just go in Chapter 7 and check it out, or go into NFPA's Chapter 8. You'll find it there. Firewall is different than a fire barrier. Why? Because it's got structural independence required, meaning one side of a building can collapse while the other side of the building stays standing and functioning. That's a true test to compartmentation and structural capabilities of a wall that protects one side of a building from the other. In NFPA, you'll find in NFPA 221 high challenge firewalls. If you go over to the FM world, they'll probably call them maximum foreseeable loss walls. They're meant to protect operations that are critical from a fire that takes place on one side of the wall or the other. Fire partitions are also rated but not continuous. Then you get into other types of barriers, whether they're fire barriers or smoke barriers. The fire barriers are probably the most common things that you'll find in a building for fire resistance rated construction, used for fire rated separations, mixed occupancies, incidental uses, exit enclosures, shaft enclosures. They're all over the place. And they're used to separate spaces for egress, to protect property from one place to another as required by code. And this is where the, quote, above code construction can take place. The building code says that if the occupancy is basically the same, you know, I sit in an office building and the people next door to me have same type of occupancy. They're using the building as an office. Some building owners may choose to be more competitive in their marketplace to put a fire barrier or a smoke barrier in between offices. They could do that. Does that mean the general contractor doesn't have to build to a specification because they know the code is less than is required? No. The scope of work dictates what is required in a building. The architect engineers to communicate the minimum requirements, code requirements, through the construction documents. But the building owner manager could say every office, every separation between the office is a 1 hour rated construction that has an air leakage rating for the fire stopping of whatever the number is. They can do that if they want. Why? Because I keep my office a certain way. It's got piles of paper all over the place. Fuel load might be way above the person next door. Maybe the person next door has way too many plastics all over the place. I don't know. Whatever it is, the building owner manager can use that as a marketing tool to market their building over somebody else's. Smoke barriers are also used in buildings, typically used in healthcare occupancies, sometimes in other occupancies as well. There's some differences between NFPA 101 and the International Building Code when it comes to fire stopping on these. The NFPA 101 does not have a quantified rating for the L rating, whereas the International Building Code does. The International Building Code says less than 5 cubic feet per minute per square foot of opening area, or less than 50 cubic feet per minute per 100 square feet of wall area is required, and that's at both ambient and at 400 degrees Fahrenheit, so cold smoke and hot smoke. Very specific in the International Building Code about what kind of L rating is required. What does this mean to specialty fire stop contractors? It means that somebody has to count up the penetrating items that go through a fire barrier or a smoke barrier, actually through a smoke barrier. Then they've got to figure out, okay, what's the L rating of that penetrating item with the fire stop system? And then add them up and see if it's greater than 50 per 100 square foot of wall, so that's a 10 by 10 area, or are any of them less than or greater than 5 cubic feet per minute per square foot of opening area. Certainly that can be done through the design side by organizing the penetrating items and where those service items run in a building. But it also means somebody's got to keep an eye on the other end of the game at the installation section and report to the general contractor that you've either exceeded or not the area. And then appropriate measures can be taken to either get a variance or fix the area such that you comply with code. Secondly, the NFPA, again, doesn't have a quantified L rating required. However, if you think about it from a fire resistance rated construction perspective, this L rating is a UL test that says that there's a suitability for use statement of a fire stop product in a smoke-resistant barrier. It's a UL standard, not an ASTM standard, a UL standard. So does that mean that the laboratory has to be UL? No, it doesn't. It just means that there has to be an L rating and a test done using UL 1479 or UL 2079 when it comes to joints. What does a professional fire stop contractor do? They know that the suitability for use statement for a smoke-resistant product is that L rating. Anything else is something less. If there's an event that takes place and somebody dies, major damage takes place, and the fire stop contractor or the contractor that installed fire stopping from the trades that has no idea about our industry installed something that they call, quote, a smoke seal that has no L rating, how do we think the judge is going to treat this, especially if somebody dies? You can hear the questioning now. Mr. Contractor, have you installed fire stopping? Oh, yeah, I've been doing it for 15 years. Mr. or Mrs. Contractor, have you ever attended a webinar? Have you ever looked at a UL system where it says L rating? Oh, yeah, I know that L rating stuff. That means smoke something. If you know about it, even if you don't know about it, and you call yourself a fire stop contractor, you've been installing it for 10 or 15 years, you say you're good at it, why wouldn't you have used an L-rated assembly, which is the industry's quantification and suitability for use statement for the product and specific application? Why would you not have used what is truly been called by the industry in a consensus standard that protects against smoke in buildings? And you can hear the contractor going, uh-oh, I am in big trouble. Somebody just got me. So really, if you think about it, whenever smoke is mentioned, whether it's a rated assembly or not, the L rating is really the suitability for use statement. Why do I say even if it's not a rated assembly? Think about it. A gypsum wallboard, gypsum assembly, 5/8" thick, maybe it's not rated. Likely it could have passed a half-hour fire-rated assembly. Likely it might, if the studs are close to that in the spacing, et cetera, et cetera. Again, approximating as close as you can to the assembly. Maybe it's a metal pipe. Maybe it's cables going through the wall. Maybe it's a head-of-wall assembly. Somebody asked for smoke resistance. The smoke resistance standard is the L rating. Using it in something that approximates it closely, that'd be gypsum wallboard, concrete block, a metal deck, you've gone as far as you can go with your due diligence as a contractor by installing the appropriate system in there. So now, what about variances? I'm not sure this is the right place to talk about variances. Variances is in this section. Where do the variances come in? Let's talk about minimum code requirements. From a contractor perspective, let's say the contractor shows up and there's no way in God's green earth that they're going to meet this L rating of 50 cubic feet per minute per 100 square foot of wall area. Somebody messed up along the way, the design professional, the general contractor, whatever. In the contracting world, the Firestop contractor has a contract with somebody. Could be with the mechanical contractor or the electrical contractor. The electrical contractor has a contract with the general contractor. General contractor has a contract with the building owner and manager. Using the construction communication channels, which would be through those people and those companies that I just talked about, the Firestop contractor can ask for a request for information and mention that there's a variance to the code if they know the code. Once that mention takes place, the communication goes up to the design professional. The design professional, general contractor, try to work it out internally to come up with a solution that makes sense. If no solution is able to be reached, then the building official can be contacted for a variance of some kind by going over to the section 104.11, alternative methods. The building official can make a determination. Is this going to affect fire and life safety in a building? And make a decision. Will they grant that variance or will they not? They may not grant the variance because they feel that it affects fire and life safety in the building too much and puts their community at risk. They may grant it. That's the power of the building official. They can't do that. It's a great question that just came up. Thank you very much for asking that. Somebody mentioned building above code. Does this mean I can use a 3-hour system on a 2-hour penetration? That's a great question. When it comes to penetrations and fire stopping, systems rule. For instance, a 3-hour fire stop system may require a certain thickness of fire stop sealant to make that work. Maybe the wall depth isn't deep enough to get all that fire stop sealant in there and have it such that it's bounded by gypsum wall or by concrete block in that annular space. Can't always say you can use a 3-hour and a 2-hour. Can't always say you can use a 2-hour and a 1-hour to make it work. Find the system is the way to go. Another question came up: ordinarily, which is more restrictive, the International Building Code or the NFPA, and which is the governing code? Code requirements are, in the U.S., governed locally. The building codes are published and worked on nationally, obviously. The NFPA has their Fire Protection Features Committee. I sit on that committee. We go to meetings and go through a 3-year cycle to come up with the NFPA 101 code or the NFPA 5000 code. The International Building Code, through the International Code Council, has its code hearings that take place this coming April, the last 2 weeks in April down in Memphis, to debate what is going to become the 2018 building code. After that building code is published, municipalities will look at that code and then have legislation drafted that goes through the political process to adopt or not adopt that code in that municipality. Certain states, like the state of Illinois where I live, have a requirement at the state level that if the municipality doesn't adopt the code, whatever code it is, that it then falls to the state building code, which uses the international family of codes for the building, and then NFPA 101 for the fire code. So where does the jurisdiction come from? How does it come from? Locally, the municipalities in the USA adopt their own codes, not their own, the model codes. Some may amend it with certain things that are unique to their area. Some may not. The National Building Code of Canada works pretty much the same way, only its development process is similar to the NFPA, where a small committee of 20 people with public input provides debate to come up with the National Building Code of Canada, the National Fire Code of Canada. The provinces then adopt those codes. They may amend them along the way as well, just like happens in the U.S. Thanks. Great question. Somebody asked about the PowerPoint. Will it be available later? Yes, it will at FCIA.org. Give me a couple hours to PDF it and put it up. Later today, you'll be able to find it up there. So thanks for those questions. Another question came up about L ratings. The question is, if manufacturers lack in the amount of tested listed systems with L ratings at owner's request, then how can the fire stop contractor be liable when very few systems meet this requirement if using the system approach and it falls short? That's a great question, and I'm going to save the answer for that question when I get to engineering judgments. The way the philosophy works, if you look at the FCIA Firestop Manual of Practice, you look at the FM Approvals Program, the UL program, if you look at the International Firestop Council's documents for engineering judgments, the recommendation to the industry is that tested and listed systems should be used first when available. What does that mean? That means if a manufacturer hasn't tested many, and a manufacturer B has tested tons, then before an engineering judgment's used, switch to manufacturer B and use that. That means going through the submittal process again. Is that difficult? Can be. Is it going to take time? Yes, it is. What does that mean? That means a specialty firestop contractor has to select a manufacturer that has a wide range of tested listed systems for that particular project, that meets the L ratings, that meets the movement criteria, that meets the joint systems, head of walls, perimeter fire containment systems. That systems approach is important to follow because the tested and listed system wins first. Engineering judgment comes later. Engineering judgment only comes after that contractor has looked at the whole universe to see if there's another system somewhere. How do you do that? It's easy. Call the manufacturers. They know each other's systems because it's a competitive world and they'll find it. Great question. Thank you. So we talked a little bit about requirements, code requirements. There are fire-rated walls that occur all over the place. Exterior walls occur where the building may be too close to the building next door, and fire resistance rating is needed for that exterior wall. It's used in firewalls, fire barriers. These systems, these barriers are used throughout buildings, throughout the world. How's it made continuous? Yeah, fire stopping is something that does it, but the other thing that does it is the fire-rated doors, dampers, hardware, glazing, all that kind of thing. Somebody asked about nuclear power plants earlier on. Many of these products were designed for nuclear power plants. The firestop industry got its start actually in shipbuilding hundreds and thousands of years ago by building compartments that if they fill up with water or fire, they won't spread to another part of the ship and sink it. Nuclear power plants use the same type of protection to protect against radiation, explosions, fire, smoke from moving into critical areas in that nuclear power plant. So many of the firestop products have already been tested for radiation resistance. Check with the manufacturer to know whether or not the radiation resistance meets the requirements for some of the key critical containment areas. In other parts of the plant, non-containment areas, firestop materials may be able to be used in firestop systems. Check the specifications, check the nuclear power plant requirements. I can't tell you that I'm a nuclear power plant designer. Check with those that are really intimate in that. Blast strength needs to be checked. Chemical resistance needs to be checked with the manufacturers. And biological resistance needs to be checked with the manufacturers and the industrial hygienists as well. Effective compartmentation is important for all kinds of reasons. Smoke control is one reason. Airflow in buildings is another reason. Someday they're going to figure out that it helps with energy resistance as well by compartmenting a building and controlling where that air goes. But effective compartmentation is used in all kinds of occupancies. We've talked about this before. I'm just going to spend a very quick second on it. Fire resistance rated construction exists in a lot of different types of buildings. We constantly hear at the building code hearings, sprinklers are 99.99999% reliable, therefore buildings are safe. It's been our perspective as FCIA The buildings are safe for, yes, sprinklers, but for a lot of other reasons. The building officials that spend countless hours doing plan review, doing inspections, making sure that the building complies with code, huge. Secondly, educating building occupants to get out. For instance, this building, this is the Cook County building in Chicago. The building burned in 2003, 2004. 21 people died in that structure. Chicago passed an ordinance to fix that through code requirements. In other words, the building officials, the building and fire department got together and figured out a way to fix that problem, allow access to other parts of the building such that the doors are not locked. And those people can then get into safer parts of the building and find other exits. But there's other reasons why buildings are safe. Alarms and detection systems notify people to get out and do something. The effective compartmentation in buildings keeps people safe. Looking at some statistics very quickly, in North America there's 11,000 tall buildings, 20 stories and higher. 70% of those buildings are in New York, San Francisco, Los Angeles, Chicago, Honolulu, and Toronto. If 70% of those buildings are in there, then the statistic that says that the sprinkler caused the safe building can't be completely true. Does it help? Absolutely. Does it increase the effectiveness of effective compartmentation? Yes. The numbers go up significantly when a compartmented building, a high fire resistance rated construction building, has sprinklers added to it. But the sprinklers were added to these buildings because a huge stock of older buildings sits in Chicago, New York, and San Francisco. And then when you look at San Francisco, Los Angeles, Toronto, or Honolulu, earthquakes take place there, which knocks out the power supply, which could knock out a sprinkler system. Therefore, the fire resistance, the compartmentation makes sense to help keep that building safe. All the above are needed. Can we take them all out and just have a sprinkler system? I don't think so, nor does the associations. So we believe buildings are safe because of all of these things in a building: compartmentation, sprinkler alarms, and egress strategies. In Chicago, for instance, after this fire took place, the fire department educated all the building occupants to teach them about egress strategies and how to get out of a building. Stage here, wait till there's a uniformed person possibly to guide you, wait for verbal cues, a person on each floor who is the leader that will guide you from place to place. Lots of different things took place. Lots of training took place to save people in those buildings. The National Institute of Standards and Technology, NIST, mentioned in the World Trade Center 7 collapse. That's the building that fell down even though it didn't get hit by one of the jets. That improved compartmentation in tenant areas to limit the spread of fires could have helped on the structural collapse that took place. So in order to have fire stopping, we've got to have all these things built correctly. The fire-rated floors, the walls, the dampers, the fire stopping, all need to be built correctly. Tested and listed systems is how we get this done. A professional person who looks at the plans and understands what those plans are. Then that person and the company have to select the appropriate fire stop systems to make sure it works. And they've got to get it installed to the tested and listed system. This is where the rubber meets the road in the fire stop industry. The tested and listed systems are where most of the issues show up. For instance, take a look at this UL system right out of the UL directory. Many of the manufacturers publish these directly from the directories, whether it's ULs or FM approvals, whatever it might be. This system, CAJ 1155, has been tested to both UL 1479 and then the Canadian standard ULC S115. These two standards are basically the same. Fire resistance is the same, temperature rating is the same, how the hose stream is applied is the same. The only difference between these two is that in certain penetrating items, the pressure in the furnace in the Canadian standard, ULC S115, is higher than the US UL standard. My guess is the plastic pipe industry wanted to make it a little harder for the plastic pipe industry to get in, so there's a higher pressure in the furnace. Many of the manufacturers have tested both, and they've got systems for both. So as far as performance goes, you're able to find a wide array of systems for when that's required in plastic piping, usually in multifamily residential, around certain types of plastic pipes. Otherwise, everything's the same. Air leakage rating's the same, T rating's the same, F rating's the same. In Canada, the H rating, the host stream test, is not mandatory all the time. In the U.S., it's mandatory all the time. Very few exceptions for the host stream test in Canada, very few. It's a very important test to show robustness of those assemblies. Looking at this fire stop, it looks pretty simple when you look at the picture. There's a lot going on here. There's a sleeve that's located in the cast in place. It's a fire stop assembly that takes place at the level of the floor. There's some mineral wool, penetrating item, etc. Take a look at the sleeve. In this case, it shows a 32-inch sleeve cast in place and calls out Schedule 40 or heavier steel pipe, cast or grouted into the floor. So we show up to the field and there's a plastic sleeve. Guess what? Got to go find another system. Doesn't mean somebody's got to tear out the fire stop. It means they got to find another system that makes sense for that particular application. Penetrating items are all listed in the system, and then the recipe to install the fire stop is here as well. Question might come up, is this all I need if I'm the fire stop contractor instructing my installers? Is this all I need to get fire stopping installed? No, it's not. The manufacturer's installation instructions are critical to getting fire stopping installed properly. The fire stop system only tells you what the requirements are and what the limitations are: annular space size, sealant thickness, what type of penetrating item, what type of sleeve it is, what type of floor or wall it is, and then what type of fire stop product's in there and how thick. That's all described in the tested listed system. The physical properties, when you can install it, what do you need to do to the product once it's in, are not explained in these tested listed systems. For instance, the spaghetti method of fire stopping, where caulk tubes make a bunch of long tubes, if you will, and people just leave it there without tooling it or smooth it, that is not explained in the system design. That's explained as to what to do in the manufacturer's installation instructions that are either printed on paper, gathered from a website, delivered electronically on a PDA or on a phone or on a tablet, whatever it is. Those installation instructions are critical. Believe it or not, the only place you'll find the transportation limitations, temperature and all that kind of thing, are typically on the MSDS sheets or safety data sheets. Important, critical information to have on the job site as well. Looking at another system, that one just happened to be a Hilti system. This system has no sleeve at all. If you scroll down and take a look, there's no sleeve described whatsoever in here. It just describes a metal pipe through a concrete floor that can be offset with a certain annular space, 4.5-inch thick floor, or any UL classified concrete block. All of this is described in the tested and listed system. But if you notice, there's no sleeve. Sleeves are used in floors by mechanical and plumbing engineers to prevent water from going from floor to floor. They're everywhere. If you go in any high-rise building, you'll find sleeves in floors to protect those areas. The other thing you'll find typically is that the sleeve extends 2 or 3 inches above the floor. Why? Because that sets up a water dam to keep the water from dumping down to the floor below. Take a look at this sleeve. It shows the sleeve flush with the floor. I'm only showing it because it's an example of what may not occur in the field. The fire stop contractor knows to look for a tested and listed system that has a sleeve that extends 2 inches, 4 inches above the floor, 10 inches past the wall, whatever it might be, that can be physically installed in that area. If you think about it, if the sleeve was sticking up 4 inches above the floor and the fire stop is supposed to be, as it shows here, that the fire stop material is flush with the top of the sleeve for floors, both ends of the sleeve for walls. So top end of the sleeve, flush with top end of the sleeve. Look at what it says for the sleeve. The sleeve has to be flush with the wall or floor assembly. So if this sleeve is extending 4 inches past the wall or floor, it's a violation. We've got to go find another system. That's a big problem. If the contractor didn't know it and went and installed thousands of these and then has to go find another system that makes sense for it. All of these really, many of the manufacturers, you never say all in anything, many of the manufacturers have already tested for those goofy situations that I just mentioned. Are they goofy? No. They're common conditions that happen every day in buildings that are built throughout the world. Do these sleeves change from metal to plastic? They do, especially in cable type situations, because when pulling cables, you don't want to break the jacketing of the cable on sharp edges of sleeves. Looking at another system, this is the oldest plastic pipe system there is, CAJ 2001. It happens to be a 3M system. Take a look at this. It's got all the different ratings. L rating of 7 at ambient and at 1 at 400. What happens when in a smoke barrier? To count up for the 50 CFM per 100 square feet of wall area, we'd have to use the 7 CFM as the number. Why? Because in the building code it says and 5 CFM and the 50 CFM per square foot of opening area. I'm sorry, it says and ambient and 400 degrees. My apologies. So it says ambient and 400 degrees. So we got to measure at the worst case, 7 CFM per square foot of opening area. And then take a look at this plastic penetrating item. Annular space is engineered to be pretty small. 3 wrap strips are installed. Likely it's a 4-inch plastic pipe. A collar has been installed. The collar is there to hold the intumescent wrap strip, which is supposed to expand at the same rate that the pipe is melting, and crush the pipe, forming an insulating char inside this area that will stay fire resistant for a period of time, 1-2 hours. 2 hours is what's called for here in this assembly. Note that the collar is bent at 90-degree angles. It'll say it in the description later on that all of these things have to be 90-degree angles. So as an inspector, if you show up and it's at a 45-degree angle, it's a reject. Does that mean that the contractor has to remove it? No. They have to find a way to get that tab to be bent at 90 degrees. Fasteners are fastened into the wall or the floor. In this case, it's concrete floor using steel fasteners. In a gypsum wall, it would be something different. It would be a toggle bolt of some kind with a fender washer on it specified in the system. And then I'm not going to read this system, but take a look how long this thing is. It talks about all the penetrating items. It talks about the fire stop system, and then has a table about what types of materials and how many of them are to be used. Moving forward, it talks about what material it is, what the manufacturer is, what kind of caulk or putty is there. And then take a look at this. Under Section B, there's some caulk sealant or putty that's not been shown. That's supposed to be applied to the outer perimeter of the wrap strip at its interface with the wall or the floor surface. Somebody that doesn't read the drawings or the designs and only looks at the drawings would miss that. So no, you don't have to be a lawyer to do fire stop systems, nor an engineer, but somebody has to be very clear about the installation instructions that are given to the workforce to get these things installed to the tested and listed systems. Without it, it's craziness. Question came up. This UL assembly shows the fire stop collar installed at the bottom of the concrete floor instead of the top. It's a critical point. Fire is supposed to heat up these intumescent wrap strips. It's the heat that makes the intumescent wrap strip activate. If the fire stop were located at the top of the floor, this penetrating item would have to melt. That takes 7 to 10 minutes. And then the fire would have to get hot enough above the floor to activate the intumescent wrap strip and make it crush the pipe. Probably not going to happen. not probably, it won't happen. Why? Otherwise, we'd have a test system, a tested system that shows the fire stop on top. In this case, well, in this type of application, that does not exist. We've not seen that in any of the systems. Moving on to other types of assemblies. This one is the open path devices. This one happens to be from Specified Technologies with 3 different open path devices ganged together. It looks pretty easy, but again, we'll look at this assembly. It's going to have certain types of cables that are able to penetrate the assembly. These types have to match in the field exactly, such that if it were different, if there were a copper pipe going through there rather than a cable, it'd be a reject because that's not part of the system. Certainly this system, if you look at it, has all kinds of different penetrating items. But take a look. It says how many of each penetrating item can go through. 3 copper conductors, maximum 12 core, maximum 30 pair, maximum 300 pair of cables. These are very specific systems. They spell out the penetrating items, and again, they spell out the device. Manufactured by various companies, whether it's Specified Technologies, Hilti, 3M. They all have their own devices that work for these types of applications. Then getting down to the Series 8000. This one, again, is one of the older ones with a composite sheet. Somebody might ask me, well, hey, Bill, you just said a couple of minutes ago that the plastic pipe penetrating item showing the system from the bottom isn't appropriate for that CAJ 2001 system. Yes, I did say that. That's because this system says use the intumescent wrap strip from the bottom. Now you're going to say to me as a question, hey, Bill, you've got the intumescent composite sheet sitting at the top of the floor and anchored to it. But take a look at a difference here. From the fire performance perspective in the test laboratory, the intumescent composite sheet has been applied to the top of the floor, but the Firestop wrap strip is actually located in the penetrating items, or by the penetrating items, such that they're exposed to the fire very quickly and very closely, directly as well. There's intumescent wrap strips that's centered. If it's a 2-inch wrap strip, it's centered such that there's about an inch above, a little under an inch above, and a little under an inch below the composite sheet, so that when the fire comes up and into this annular space, it activates the wrap strip to crush the insulation, to provide a fire resistance and smoke resistant property to these cables as well. So yes, it's at the top of the assembly, but look how big the annular space is. And more importantly, the tested and listed system shows that the Firestop materials can be applied at the top of the floor. That's critical. If in the system it shows that the Firestop materials must be assembled at the bottom, you have no choice. You have to install that Firestop material at the bottom. So a great question. Thanks. Questions that come up, here's one that says, the largest problem with installation of these, especially maintaining these systems, is when IT companies come in later and use the existing. Who's responsible? Great question. That's addressing the CAJ 8001 type assembly where there's multiple penetrating items. Could even be a single penetrating item. Let's say it's this guy, the CAJ 1149, and the cable guy said in the wall shed, look at this annular space. It's open. I'm just going to run my cables right through that guy's open hole here. The violation takes place. The system isn't there. Who's responsible? Your submittal, if you're a Firestop contractor, showed a penetrating item without it. If you document your systems, and many contractors document their systems with pictures. They send their mechanics out with digital cameras, digital phones, and they take a picture of every Firestop system. Some of them label them with the Firestop system number on them, and catalog them for their own liability for that particular reason. They, as contractors, can also offer that as a value add to the building owner and manager afterwards. Say, look, fellas, I took pictures of everything you have here. Whatever deal they work out with the building owner or manager, whether they pay for it or not, the contractor can then say, I'd like to set up a maintenance program with you and maintain these assemblies so that when the cable guy, the oxygen piping person, the med gas people, whoever goes through those walls, they can fix them. That's a way to control that, is document it. So what do we have to do with the sealant application when the sleeve is 2 inches above the floor, flush with the floor and with the sleeve edge? So that's a good question. What you need to do is come back and find yourself a system that allows this. Let's go back to one of the other systems. I'm going to plug in CAJ 1175. 1175 shows the Firestop sealant at various places. This one shows the Firestop sealant down at the bottom of the floor. It also shows it, in this case, though, flush with the floor. I can tell you that there's a lot of other systems that show the Firestop sealant installed at the top of the sleeve rather than at the plane of the floor. So what you do, you go find another system. That's how you get that done. So let's go back to the tested and listed assemblies here and do the slideshow and talk about it. I'm not going to spend a lot of time on testing. We're an hour into this. The testing is what sets the suitability for use statement of the Firestop product and specific application. Yes, testing is important, but what's really, really, really important is knowing how to select the systems on the left and then look at the penetration on the right and have that system be installed right. That's the contractor's issue. Okay, now let's go to the next step. What's the inspector's issue? The inspector's issue is they come to the field and see that there's Firestop materials installed around all these penetrating items. The inspector's job is to then take what submittal has been provided by the Firestop contractor, electrical, mechanical, plumbing contractor, through the communication channels to the building owner, manager, and or architect, who is tasked with hiring the special inspector, or in buildings where special inspection isn't done, those submittals are then given to the building code official, who has to do his or her inspection. And I'll show you in the code where it talks about that inspection here shortly. Those systems are used to judge the fire stops that have been installed. Without this system, they can't judge whether the fire stop has been installed properly. That's what all these test standards do. The ASTM E814, UL 1479, FM 4990, the ULC S115. The test method results in the system. The system is what guides us. The products are used by contractors to get installed to the various areas of the building that meet the physical requirements of that building as well, and meet the physical requirements of the penetrating items. For instance, this picture on the right shows a Firestop mortar product. Mortar is a cementitious-based product. If you were to ask the Copper Development Association, is concrete and copper compatible, they'll say, no, there's a galvanic reaction between the copper and the cement and limes that are in the concrete mix. Therefore, they're not compatible, and we don't recommend those two things touching. Therefore, there might be a Firestop system that shows fire stopping being applied around copper, but the physical properties of the copper say don't use cementitious-based products. There's also a memo out by the Copper Development Association that says be careful about latex acrylic products used in around copper penetrating items. That's also critical. That means that the Firestop manufacturer, and all of them have done this, need to have some kind of suitability for use statement to the contractor that says that they believe their products won't affect that copper. Copper Development Association still has that on their website. to check acrylics and copper. Firestop materials, many of them are latex-based. That means it's acrylic. So therefore, check with the copper development, check with your manufacturer partner to make sure that their products are compatible with copper and any of the other products that are out there. Secondly, what happens when this penetrating item, as it goes through the floor or the wall, whether it's a metal pipe, copper pipe, insulated pipe, whatever it is, it's hanging from a ceiling as it penetrates that wall. Maybe the floor above that is a parking garage. What happens when there's movement of that penetrating item and the wall under it stays static because it's not moving, only the floor above it is moving? The FCIA asked the manufacturers through the ASTM process to come up with a standard that allows for some of that movement. The architect engineer has to design for that as well and communicate through the construction documents that there's movement going to take place. Firestop contractor then goes to ask the manufacturer, what's the movement capabilities of these products? There are capabilities of the products. Some are better than others, obviously. Concretes are going to be quite restrictive and not allow for much movement. But some of these other products, whether they're Firestop sealants, Firestop bricks that are made of foam, may allow more movement than things that are anchored to the wall, solidly concrete, et cetera, et cetera. So all of these products have various physical properties. Sealants will be able to be compatible with various water chemicals, might be even water resistant to stop water from flowing from one floor to the other. These are all very important things to remember, especially at the design phase by the professional specifier. There's wrap strips available, putties, pillows, composite sheets, fabricated kits, mortar, spray products. Look for a webinar here shortly later this year. We'll probably do it quarterly to try to give those that are interested the advantages and disadvantages of every type of product that's offered in the Firestop industry. If you want to study it extensively, the new Firestop Containment Worker Manual and then the new Chapter 3 of the FCIA Firestop Manual of Practice, those two documents have about 600 pages of this. Now, mind you, some of that 600 pages is tested and listed systems, but we did a huge, extensive update in 2014. Read about it, learn about the products, and we went to all the various places to find information generically so that you can cover the whole industry in one place. What about fire dampers? Fire dampers are tested to a different standard, UL 555 and 555S. They've got to be installed to the manufacturer's instructions as well. Fire stops can be used around fire dampers as long as the tested and listed system allows it and as long as the AHJ allows it. So again, match the products to the physical properties of the building. Is there germ resistance required, chemical resistance required, radiation, biological resistance required, and then match it up to the products that are there. System selection and systems analysis is really what makes this industry tick. The Firestop contractor has to choose the right system for the right application. The Firestop Special Inspection Agency and the inspector working for them has to analyze those systems and make sure the right ones are used. The AHJ isn't paid to be a special inspector, and they're not paid to be the contractor's quality control department. The building official's responsibility is to make sure that the fire stopping's there, yes, but not to be the quality control agent. That's why the building owner hires a general contractor and all the subcontractors. That's their job. Does that mean that the AHJ won't ask the contractor to cut open a couple of openings, penetrations, and see if the fire stop was installed to the system? Not at all. Does it mean that they're not going to do an extensive inspection? Don't know. Depends on the jurisdiction. Depends on whether the building owner or manager maybe even paid a little extra to the community to have a super strong inspection done. So systems analysis, system selection, that's where it's about. Especially contractors got to know all of these things, the F rating, the T rating, the hose stream test. That hose stream test is there to provide shock, not necessarily waterproofing. It's a means to apply a force to that assembly to make sure it's got a robustness and stays in place when the ceiling tiles are falling, the light fixtures are falling, and hitting that fire resistance rated assembly. If any water gets through the unexposed side, it's a failure. The various directories, UL, FM, Intertech, they've all got the systems. We spent a little bit of time talking about them, whether it's a head-of-wall system or a penetrating item system. Those systems are important to, not important, mandatory to know, and mandatory to be able to judge whether the fire stop contractor got it right, or if they chose the right system and accept or reject that application. The other critical thing to know on these systems is, if you take a look at this metal deck concrete composite assembly, just looking at the picture that's on the screen on the right, you can see that there's no fireproofing on that metal deck. Come over to the picture down here down below, and it's clear to me that there's a cementitious-based fireproofing that's been sprayed, spray fire-resistant materials for an hourly rated either roof deck, floor assembly, whatever it might be. As a fire stop professional, looking at this tested system, I'm seeing that there's a violation already because there's no fireproofing on the bottom of the wall or the bottom of the fire-rated floor or ceiling, whatever that assembly is. So I'd be looking for fireproofing on this tested and listed system, and there's lots of systems that exist that have fireproofing on them. So this is not an anomaly and not something that can't be done, but it's part of the system. Whatever this fire stop product is testing or touching has to be part of the tested and listed system assembly that was run through the fire test. These gypsum fire-rated walls have to be built as shown in the tested and listed system. This is showing a 1-hour assembly constructed to a U400 wall probably. If that U400 wall assembly allows a very wide spacing, as you can see here, it looks like a wide spacing to me. If it allows that, then that's fine. What if the wall's not built correctly? Is that the fire stop contractor's problem? Well, the fire stop contractor probably ought to say something, not probably, is under obligation to say something to the general contractor they're working for, that the wall doesn't seem to meet the rating requirements for the wall itself, and then try to, through the construction process, get it repaired such that it matches what is required. Not the contractor's, fire stop contractor's responsibility, but it's the responsibility of the contractor to make people aware that they can see a variance. Question came up about fire dampers, that the use of a fire stop material around a particular size could affect the operation of the fire damper. That's a very good point. Let me back up just a little bit to the fire dampers. Fire dampers operate independently of fire stopping. It's a motorized system with a bar, they call it a jack, that rotates to open these dampers so that there's clear airflow through. When a fire comes, to stop the smoke and fire, they then rotate and close. The fire stopping that's applied on the side of this has been proven through testing that it may work. Not may, does work. The only time we know it works is when there's a tested and listed system for that damper assembly that allows the use of fire stopping on it. Otherwise, both sides of the wall don't get any fire stopping, but get these angles that are welded at the seam, or welded at the corners, so that it's a continuous angle all the way around the fire damper. The only time that fire stopping is allowed is when testing allows it and when the AHJ allows it to. Great question. Thank you very much for asking it. Back to the systems. Here's the key questions that the professionals need to know. What's the wall or floor? What's the penetrating item? Does it have insulation on it? What kind of insulation? Is it a plastic pipe? What kind of plastic pipe? And then what are the rated fire stop systems used to make that work? Are the penetrating items installed into the walls or floors through them to create the opening? Are they off-centered, in the middle, off to the side, continuously touching? How are they working? And then will the system explain that? Down to engineering judgments. Here's what we talked about. Protocol is, if you can't find a system from the manufacturer you submitted, find another system from the same manufacturer first, go to a different manufacturer second if no system exists in either case. And this different manufacturer could be any of the manufacturers. Again, this is where you really need to rely on the technical departments at the manufacturers of the fire stop products. They know each other's systems like there's no tomorrow. Why? Because that's their competitive advantage. Have the testing that's more competitive, that keeps the contractor faster, better, cheaper. All of these guys know each other's products and they know their systems very well. Ask the manufacturer, what other system should I use? Make a phone call to the other manufacturer if you need it. If you can't find a system, then we go to an engineering judgment, or as FM calls it in the FM 4991 program, an equivalent fire resistance rated assembly. The International Firestop Council, which is the Manufacturers Association of Firestop Manufacturers, has this website, firestop.org, or I'm going to post it this afternoon, the IFC guidelines for evaluating engineering judgments. And these are guidelines. And the guidelines say that construction industry professionals, etc., need to evaluate these guidelines for evaluating and using such judgments. So the industry association has said others need to make the decision whether these are suitable or not. Building officials, contractors, and others. Especially firestop contractors ask their manufacturers to put on the engineering judgments that the manufacturer believes that this approximates and will pass the fire test if it's subjected to it. That's a critical responsibility issue that the contractor needs to put on the manufacturer. We hope that the building official does the same, and maybe that's a code change proposal someday that comes forth, that the engineering judgments have to be have some kind of statement that puts the responsibility for the suitability for use of that product in a specific application where it belongs, back at the manufacturer level. Contractors don't know how these things burn because they're not at the fire tests. The only people that really know how these things burn and really rate is the manufacturer standing next to the fire test and then the testing laboratory as well. So I'm not going to go through these guidelines one by one. Be aware that I'll put it up on FCIA.org on the home page in the hot news this afternoon. But look at all these requirements that are in the guidelines for evaluating engineering judgments. This is several pages. I'm going through slide after slide of what the engineering judgments are. These are not to be taken for granted. And secondly, they do occur on buildings. It's not like every manufacturer, although they've tested 9,000, 10,000 systems depending on where you are, which laboratory you look at, there's still cases where engineering judgments come up. Buildings shouldn't have a ratio of 90% engineering judgments and 10% systems. It should be the other way around, and I can't give you a specific number of what that number is because I've not done the research. But by and large, it should be tons of tested and listed systems and not as many engineering judgments. So now the easy part. I've spent all kinds of time talking about system selection, hardly any time about talking about installing the products. First is the safety violation, mineral wool on the MSDS sheet. It says personal protective equipment, eye protection, hand protection. Other critical element, notice how smooth it is. Everything's got to be tooled in the fire stop industry. So if you don't see something that looks smooth and cause the material to wet into the concrete or drywall assembly, they've probably not done it right. Here's a variance that was pointed out earlier. This blue cable that's going through the plastic pipe penetration. That's exactly what the person asked me earlier on in this presentation. What happens afterwards? Well, there are some systems that may exist allowing internet cables, Cat5 cables, going through the same penetration, same opening as a plastic pipe. Find the system that matches it. Here's the sleeve thing. Another question to ask about is what's the type of sleeve? We talked about Schedule 40 in those systems I showed. These aren't Schedule 40. These are 28 gauge sheet metal with seams. So this has been applied to the wall after the building was built and after these service penetrations were made for the service items that are carrying services into the building. So the manufacturer may or may not have a system for this. It looks like the sleeve extends like 5-6 inches past the wall. Does that mean that someone has to get an engineering judgment? No, there might be a system for that. But a question just came in is what happens if there is no system for it? Does a manufacturer prepare it, or does it require a stamp by a registered fire protection engineer? That's a great question. In the last International Building Code cycle, that resulted in the 2015 Building Code, there was a debate about this. And the debate was, should engineering judgments be stamped by fire protection engineers, or should they be stamped by the, or verified by the testing laboratory? If you think about it, engineering judgments are self-certifications by manufacturers of those products. Is that something that should take place in the industry a lot? Likely not. This is the fire and life safety industry. Should it take place at all? It has to take place because there just aren't systems for every particular application. The manufacturers are spending all kinds of money, millions of dollars a year, testing at their own laboratories and at UL, FM, Intertech, Southwest Research to build a database of systems. Maybe one thing the manufacturers could do is send their technical department, just take one person, send them on a sabbatical out with a Firestop contractor for a year and then come back and test everything they found. That might do it. Who knows? It's not mandated, though, that engineering judgments have to be stamped by an FPE nationally. Some jurisdictions, though, require that engineering judgments be stamped. Not all, but some do. Good question. Thank you very much for asking that. On to things that exist that are probably crazy. Yes, this one looks crazy, but what if that were a rated floor ceiling assembly and that ceiling membrane was actually part of the fire-rated assembly? Then we'd have to find a system that allows fire stopping around penetrating items going through ceiling tile. Drywall compound is not a fire stop. Obviously, it doesn't hold up to a fire condition, hasn't been tested to ASTM E814. Inspectors need to look on top of things to make sure that they've inspected appropriately. Foams, unless that foam is past the ASTM E814 UL 1479 test for a fire stop and doesn't say as modified on the can, modified isn't something that's in the International Building Code, then it shouldn't be used. We just talked about fire dampers. Fire dampers can have fire stops in them as long as they've been tested and listed for that particular use, and the AHJ allows it. Other key things on fire stop systems, in the cable penetrations, inside the language it'll say fill around the interstices of these cables. That's huge to remember. Interstices means open up every cable and fire stop in between. Joints are another thing. Joints are where breaches occur between assemblies. The breaches are there to separate the assemblies. The joint system is used to provide a bridge, if you will, fire resistance rated to prevent fire and smoke from moving through that assembly. In an international building code, sooner or later somebody's going to put on a code change proposal that defines this better. The joint, if you look at the code, it talks about intersection, it talks about joining, etc. That's really the joint system that ties the two together. What we're really looking at is a breach between assemblies for various reasons, to separate two dissimilar materials, to provide movement in a building, etc., etc. Those are all different things, and something the International Building Code really needs to deal with, because the definition currently, a joint, defines the treatment more than it defines the opening or the breach. Joint systems are subjected to movement. Class 1, 2, and 3, those are all show up on the fire resistance rated assembly. Joints occur at the head of wall assembly, where walls come together, floors come together, at the head of wall assembly, with fireproofing, without fireproofing, with penetrating items, and without penetrating items. Penetrating items, you can see as they're going through the wall, somebody put some BX cables as the wall or floor goes through it. The fire-rated assemblies are going to vary. As you can see, this is a beam holding up a floor assembly. So the drywall or concrete block is probably underneath this beam. And then there's spray fireproofing, spray fire-resistant materials everywhere. Penetrations come where bar joists penetrate assemblies as well. Those need to be treated. But again, it's got to be done with the right stuff, installed by people that understand what they're doing. In perimeter fire containment, these systems are meant to stop fire spread from the interior of the building from floor to floor at the perimeter curtain wall assembly of the building. There's a fire test that's been done that judges fire attack from the outside of that joint and the inside of the joint. But the key thing to remember is this ASTM E2307 system only judges the interior fire spread. It doesn't judge the leapfrog. That standard has not been developed yet. However, what it does is provides the continuity of the fire resistance rated floor all the way out to the outside edge of the building at that curtain wall assembly. When coupled with fire-resistant insulation systems that are throughout the perimeter of the building continuous, it may provide some excellent fire protection. What happened at this Tamwheel apartment building tower in Dubai is that somebody threw a cigarette butt into a dumpster that was located right on the side of this high-rise building. The dumpster caught fire, spread the fire into the insulation, which then went up further throughout the building, and then ignited about the 10th floor and really flew up the building itself. Unbelievable. Perimeter fire containment system coupled with a non-combustible insulation that may have sandwiched combustible high R value insulation might have prevented that. So key thing is systems. How do we choose these systems? Systems got to be done by professionals, people that really understand what they're doing. It's not like the circus. This is what I call the Cirque du Soleil of fire stopping on the right-hand side. Currently, the way fire stopping is done is he or she who pokes the hole fills it, or a fire stop contractor does it, or a combination of the two. We see the share of the fire stop contractor being more and more as building owners and managers figure out that they're not getting the value that they paid for. The fire stop contractors understand systems. The trade contractors understand their trade. It's really hard for a worker to understand two trades, let alone understand one trade, let alone multiples. A couple of questions came in. First one is when we will have a system in Canada for the edge of slab. The edge of slab systems in Canada, the specifiers and the building officials have been accepting the ASTM E2307 standard as the right standard for curtain wall perimeter fire containment systems. Testing is done at UL. It's accepted throughout Canada from what we've seen. Second question that came in about joints is that some building contractors don't like to fire stop static joints. They claim they can use grout to close the gap since there's no movement requirement. Is that correct? That's a great question about what can be used as a product for handling joints at the bottom of the wall in non-movement rated joints. Continuity of fire resistance is what's needed. How that takes place can take place, as the code says, with generic materials or with tested and listed systems. The generic materials have to approximate the fire rating. Drywall compound used at the bottom of the wall, I'm not sure has shown that it will provide continuity of that 1 hour fire resistance rating. We don't have any testing that shows it, nor do we have any equivalencies in the building code that show it. So the only way you could get continuity of something like that would be a concrete block wall that has the equivalent thickness of concrete filling that area. The equivalent thickness of concrete is usually 3.5 to God knows thickness. It's very thick. Good question, thanks. Second question is, how does ASTM E2307 stand up against other tests with pressures? That's a good question, and I'm going to save that for the next webinar. Let's get into our next topic about contractor qualifications. That perimeter fire containment assembly we're going to use as a webinar for a later date, so thanks for asking that question. Fire stopping ratings, FTH, L, and W, these are all complex things. We just spent an hour and 15 minutes talking about systems and how complex they are. Yet the fire stop products can be bought at a hardware store. They can be bought at a specialty distributor that takes care in how they distribute materials and ask the questions about systems. They can be sold to about anybody. The manufacturers, and I got to take my hat off to all our manufacturer member companies, Specified Technologies, 3M, Rector Seal, Hilti. All of these companies are very professional, and they've invested millions of dollars training individuals in the field with a 1 hour program, half-hour program, half-day program, having people to their headquarter locations to look at their testing laboratories, providing multiple day education programs that they charge for, or sometimes they don't. Regardless, they are training people like crazy, and we really respect what they're doing with that. The FCIA is doing the same thing through our manual of practice, through our Firestop Containment Education Program, Firestop Containment Worker Education Program. We've got 22 PowerPoint presentations, 22 quizzes with 50 questions each to 20 questions each. We've got countless hours of video for step-by-step installation for the Firestop Containment Worker or the Inspector Worker. Tons of stuff going on there. So really, what are the qualifications for the companies that install? What are the qualifications for the individuals? With UL and with FM, we developed these two programs, the Qualified Contractor programs. They're company-based management system programs with individual knowledge units in them as well. Huge, huge programs that provide a company qualification. The manufacturers do offer classes. Do they offer certifications? Well, they say that they've been trained. They say they've been educated. They might give them a card that says they passed a class. But there is nothing that ties the manufacturer and the contractor together with a warranty similar to what you would see in the roofing industry, waterproofing industry, or other industries. In those industries, the Firestop or the waterproofing and roofing contractor signs an agreement with the manufacturer that contractor is responsible for 2 years, the first 2 years, for any issues. After that, the manufacturer is responsible. Very clearly written contract. Then the contractor hands the manufacturer or the building owner manager a warranty that says this product will work for 10, 20, 30 years, whatever the amount of time is. No such thing exists in the Firestop industry. That's why we developed the FM and UL programs, to provide some benchmark level of company quality that says that the company has been approved or qualified. In the roofing industry, you'll see manufacturers like Firestone, Carlisle, Johns Manville, and others have approved applicators. They at least go through some kind of rigorous, questions by the manufacturers along the way as well. What are the contractor requirements? When choosing a Firestop contractor, it's the same as choosing any other contractor. What's their insurances? Are they insured as a specialty Firestop contractor or a plumber? Why is that important? Because how they classify their workers covers the workers' comp insurance. If they're not insuring them as working at height, working above ceilings, maybe working in confined spaces, then who's going to pay for the injury if something happens? Usually the state, because it might exceed the insurance that's taken place. Who knows? Secondly, the finished product is a Firestop, not a plumbing system, not an electrical system. Their classification will judge what that finished product is. What's their workforce? Have they been educated as a Firestop containment worker? The FCIA put together that education program for a 4-year Firestop containment worker. There's been a trade declared in the states of Oregon and Washington already, and look for that to spread throughout the country in 2015 is one of our goals. And then, are they FM, UL, or ULC qualified? What are these UL programs and FM programs? They're management system-based programs. In the 1950s, there's a guy named Edward Deming who traveled to Japan as a consultant and consulted to the Japanese as they built their factories after World War II, and built the management system concept, that a management system will properly managed, properly organized, and properly specified will result in a quality product at the other end. In the 70s, the Japanese product then wound up clobbering the U.S. product in the automotive industry, such that in the early 80s we were all buying Toyotas and Hondas because we felt that the Fords and GMs weren't quality products like those Japanese. In the early 1980s, Ford reacted with quality as their job one. They became ISO 9001 accredited organizations, put together management systems for their operations, and as a result, their quality got better. The Firestop industry looked at that same model 15 years ago and said, how can we make the contractors, how can we find a way to provide an opportunity for the contractors to make their companies better voluntarily? The result was FM 4991 and the UL Qualified Contractor Program and ULC Qualified Contractor Program. These programs are modified or modeled after the ISO 9000 system. Same program. Build a management system, have a management system audit, and then have a job site audit by the auditors from a third party. In this case, Factory Mutual, FM Approvals, or UL. FCIA could have set this up and made a ton of money and sent me out to audit all these companies. And then we would sit down over dinner, probably someplace nice, hopefully, with a glass of wine or a glass of beer, a glass of Dr. Pepper, a glass of coffee, or whatever. And the contractors say to me, hey, Bill, we're close. How about just giving it? My answer back to them would be, uh-oh, I got an issue here. This member might not renew. Ethically, I'd say, no, I can't do it. They might fire me for that. In this case, FM Approvals and UL are totally independent of FCIA. And that way, that economic influence goes away. The second requirement, third requirement, if you will, first one is for an FM or UL contractor that they have to have a management system manual. FCIA has a template in our members only section. Secondly, they got to have a job site audit by FM or UL. And thirdly, some person at that organization has to pass the FM or UL Firestop exam. This same Firestop exam is used to set a benchmark level of knowledge. It's based on the manual of practice, the FCIA manual of practice, system selection that we just went through, and then also the FM UL programs. The International Accreditation Services uses this exam as a way to quantifiably say that the Firestop Special Inspector has knowledge as well. And some jurisdictions have gone as far as doing that too. The City of Phoenix, for instance, has said this is an appropriate exam. Las Vegas has said this is an appropriate exam to qualify the company as well. So what happens? The management system is audited. That management system has all these types of characteristics in it. Has the employee training take place? What's the system selection controls? How do they communicate those systems to the field? What's the record keeping? How do you handle non-conformances? Everyone's going to mess up sooner or later. How do you fix the mess-ups? How do you document the projects? And then how long do you keep that documentation? And then where do you keep that documentation? So the management system audit is done by ULC and UL or FM. And those audits take place at the beginning. They also are the beginning, the very first audit to get the company UL or FM, and they take place annually. Every year that company gets audited. Cost is around $6,500 minimum for the UL, ULC program, a little bit more for the FM program. For the first audit for the company, you can spend that in 2 football games and 2 dinners with customers. Cheap investment in the quality management system of your company. And then the individuals, the DRIs, the designated responsible individual, has to keep learning units that turn into CEUs. They have to keep 48 of those learning units every 3 years. You can get them by attending these webinars, attending FCIA conferences as a way to get those along the way. They have to keep that, again, for continued satisfactory performance. And the whole idea of this management system concept is have a program that quantifiably verifies that the company's got the procedures in place to get fire stopping installed properly. The FM and UL people go to a job site. They may cut a couple of holes. They don't cut the holes. They have the contractor cut the holes, and then judge if the fire stop's been installed properly. It's not an ASTM E2174 2393 program. It's a check of the management system. What's the management system? Here's the management system. The management system is this. How do the companies train their employees? How do they select systems? How do they communicate those systems to the field? How do they control materials and make sure that the product is transported at the temperatures that the manufacturer recommends? How do they control those materials so that only good materials are used? What's the installation protocol? Does the crew, the field crew, have the protocol in their head that says if it's not a system, it doesn't meet the requirements, if it exceeds the annular space, that we're going to go look for another system? Does the contractor label every one of their penetrating items? And if they do, how do they label them? How do they control the labels? Do they number them? Are they barcodes? Are they handwritten? And what's the procedure for them? How do they keep records about these fire stop systems? The FM and UL programs both require keeping records for 7 years. How do they handle nonconformances? What's the procedure for nonconformances? How does the company handle documentation of fire stop systems? Where do they keep them? How long do they keep them? 7 years, again, is how long they keep them. These are all parts of that management system that are important for the company to have. At the end of the day, they'll be given a certificate from UL, ULC, or FM. And it'll be a company certificate. This says the Qualified Firestop Contractor Certificate. And then the DRI person will have a letter that says that they've passed the fire stop exam and that the company has appointed them as a designated responsible individual. If they have to be an FCIA member in good standing, then there'll be a certificate signed by FCIA for that member in good standing. Some of the manufacturers may write letters that say that the company is an applicator. It doesn't say that they're approved by the company at all. Now, what about inspection? Inspection is a very important piece of the DIIM. Why? Because inspection, installation, and maintenance all go around in a circle. The installation's got to be done right. The inspection verifies it's been done right. The maintenance makes sure that the operation of the building continues without interruption because the fire resistance rated construction works. The sprinkler guys have done a good job of this. The alarm people have done a great job of this. Those companies and those industries have annual inspections that the building owner manager has in their culture that it takes place every year. Fire resistance seems to be a forgotten animal. Why? We don't know. I think it's education. I think it's education that needs to be done by our industry to the AHJs, to the kids in 8th grade, high school, college, to the building owners and managers, and to the occupants. There's a question that came in about the integrity, let's see, what came in about qualifying a non-ULFM contractor as an AHJ. It's a very long question, so I think I'm going to have to hold it until later. So I'm going to have to hold that one until later. It's multiple paragraphs. Really appreciate that question, and I'll get to that at the end of the program. What about inspection, though? The International Building Code has a requirement for ASTM E2174 and ASTM E2393 inspection of fire stopping. The standard has very few requirements for the inspector, very minimal requirements for the inspection agency, but does tell you how many fire stops have to be tested. Currently, we're debating at ASTM the how do you test, how do you cut, how many times do you cut in the same penetrating item, and then what is acceptable as well. It's a great standard. There's great reasons for all of these things to exist. What are the inspection options? Self-inspection is done. Under the FM and UL program, each contractor that is FM approved, UL, ULC qualified, has to have some kind of a verification that they've got fire stop systems installed correctly. They don't look at 2% or 10%, cut 2% of the installed fire stops or observe 10%. But they do cut holes in the joints and in the penetrations as part of their management system. What about the manufacturers? Do they do inspection? No, they don't. They were right behind us as we were the proponent for this ASTM E2174 inspection. They don't want to be inspecting because they see the conflict that comes with the manufacturer who's trying to sell products to the contractor and telling them they really messed up and they have to take out everything and start over again. That's a really tough pickle for that manufacturer to be in. Some manufacturer model programs have that. The roofing industry does. They won't give a warranty until the roof has been done right, and they'll reject and make the contractor do more work. This industry is not there. And that's okay. That's the model that's in the industry, evidently. ASTM E2174-2393 inspection, provide independent third-party inspection, can be either destructive or non-destructive at a specified frequency. So let's talk about inspection. This is out of the 2012 International Building Code. It sets up that in 104, Chapter 1 of the Building Code, that the building official can have the authority to accept reports by approved agencies. So these are key words, approved agencies. And those inspections shall be in writing, certified by a responsible officer at the agency. And then the building expert or building official can have expert opinion to judge those things along the way as well. In 110.3, it talks about upon notification, the building official can make inspections as set forth in 110, 3.1 through 3.10. In 3.6, it talks about fire stopping. It says that the fire stopping shall not be concealed from view until inspected and approved. That approved is another word that's important to remember as well. In 110, it also talks about the building officials authorized to inspect reports or accept reports, provided the agency satisfies the requirements to the qualifications and reliability. And then there's approval required. And you can't, you, meaning the general contractor, can't move on until the inspection has been done. Now this is the academic world and the code world. We know that there's contractors that go blowing past inspections and get things done, close them up before the inspector's been there. That's really against the law because the building code's the law. It's the minimum requirement. Let's look at some definitions. Definitions are very important. This is out of Chapter 2 of the International Building Code. The approved agency is the established, recognized agency regularly engaged in conducting tests or furnishing inspection services when the agency's been approved. So look at this, established, recognized agency. Secondly, approved is acceptable to the building official or authority having jurisdiction. That's where we go back to the approval of engineering judgments, or the process, actually. The building official can approve it, or they can say, we don't want any engineering judgments. That's not something we're going to accept. That's totally up to them. Our industry may or may not agree with it, but that's the power that the building official has. It's given by the code. There's also a definition for a special inspector. The special inspector is the qualified person employed or retained by the approved agency and approved by the building official as having competency necessary to inspect a particular type of construction requiring special inspection. So approved agency and the special inspector are two different entities that the building official has to approve. These are in Chapter 1, Chapter 2 things. Now let's go to Chapter 17, which is the International Building Codes section on special inspections. These are items that have been identified by the Building Code Development Organization as important to have special inspections, typically structural, items that affect structural issues. First thing is the approved agency. The approved agency shall provide all information necessary for the building official to make sure that the agency meets the applicable requirements. And it's got some really important things in it in the building code. The building code, it talks about independence, that the approved agency shall be objective, competent, independent from the contractor. That same language sits in the ASTM E2174-2393 and then goes on even further. Secondly, the approved agency shall have adequate equipment. Then it says the approved agency shall employ experienced personnel educated in conducting and supervising and evaluating tests or inspections. So it lays out very clearly what that independent inspector's scope of work is and where the direction comes from. The direction comes from the approved agency. Who hires the special inspection agency? The owner or the registered design professional in responsible charge acting as the owner's agent. Those are critical elements because what we see going on right now is the general contractor seems to be trying to hire the special inspection agency, which is not conforming to code. To conform to code, the owner or the registered design professional needs to be doing that, acting as the owner's agent. Why is that important? Because the building owner has a responsibility ultimately for providing a safe building, complying with the building codes, working with the design professional. The design professional has the license that's held out as, protecting public health, safety, and welfare along with the building official who takes the same oath. But the liability lies at the building owner, manager, architect, and all those construction people that have been involved along the way. Special inspector qualifications are laid out. I'm not going to read this whole thing in 1704.2.1, but it talks about competency, experience, and training, on and on and on. Chapter 17 talks about fire resistance rated penetrations and joints. Fire stopping is required in a high-rise building. The special inspection is, the high-rise building is defined as a building 75 feet and higher above lowest fire department access. And then the two standards are called out. It's also required in special occupancies in Table 1604.5, which calls out buildings, education occupancies with 200 or more people, assembly occupancies with a certain threshold number of people. I think it's 500. Don't hold me to that number, but I'm not sure. I'd have to go back to the exact code section to find it, which we certainly can do. However, we're running out of time, so I'm not going to. So the special inspections require ASTM E21742393. Independent of, divested from, not a competitor of, are all part of 2393-2174. 2174 says 2 years experience, accredited by the AHJ, meet ASTM E699. There's also another way to say is the approved agency, which needs to be hired by the registered design professional and building owner, can be accredited as well through International Accreditation Services AC291. It's a company accreditation, says that the Firestop Special Inspection Agency company has to have an individual that passes the UL or FM Firestop exam, regardless of whether they're an engineer, registered design professional or not, and at least 1 year quality assurance. This has to be specified by the specifier because it's not required by code. The building official could certainly say, in order to be a special inspection agency that I'm going to approve, because that's part of the approval, I want to see IAS AC291. And then individual certifications can be there as well. We know the International Code Council is coming up with an exam, and we're looking forward to seeing that. That's probably going to be focused heavily on code requirements, which is really great because the code requirements aren't heavily into the UL and FM exam. To really be a great special inspector, it'd be both the ICC exam and the FM or UL exam to be a really great special inspector. And that's something that we're going to promote along the way, is promoting both of those programs. The ASTM E2174 process is all laid out in ASTM E2174. We'll have a program just on this as part of our webinar series. The Special Inspection Agency and the contractor look over the inspection documents, which are the product data sheets, installation instructions, test and listed systems, and the safety data sheets. Somebody builds a mock-up and they cut a bunch of holes in it, and then they randomly witness 10% of each type of penetration fire stop, no less than 5% of each of the total lineal footage of fire resistance rated joint system in each type. So random witness is one method, or cutting the penetrations, a minimum of 2%, no less than one of each type for 10,000 square feet of floor area, and a minimum of one for every 500 lineal foot of joint area is mandatory. If there's a 10% variance, the inspection stops, the installer goes back and inspects their own work, fixes it, and then the inspector comes back and re-inspects again at the same rate, meaning a pretty heavy inspection and an inspection costs. Pretty interesting things. If there's variances, there's 1 day notice after discovery to get that information to the contractor. The building code goes even further. In section 1704.2.4, it says that this has to be brought to the immediate attention of the contractor. Immediate is doable now. Everyone's got mobile phones and tablets. The cell service works everywhere. Just hit that email, quickly get the inspection deviation report to the authorizing agency, which would be the building owner and manager, or design professional and responsible charge, who communicates it to the contractor immediately. Or the process could be set up that it's verbal, followed up with in writing. And then again, in both methods, if there's a variance, the inspection stops and they start all over again. The reports are submitted quickly, There's a report requirement in the Chapter 17, and it's a critical element to make sure that the final report has all the inspection deviations, et cetera, et cetera. These special inspections are quite good. In addition to the special inspections, all the various documents should be given to the building owner and manager so they can take the building and maintain it through its life cycle. Because we know that after the building is built, things happen. What needs to go in the specifications? The accredited inspection agencies, IAS AC291, that somebody passed the UL or FM exam. Specify the FM and UL Firestop Contractor programs. Specify the various test standards. Remember that in the specification include these words. Install a single source product to the greatest extent possible. As soon as those 5 words are there, that allows for an engineering judgment. It allows for switching to another tested system. The FHT, L, and W rating's got to be specified, and then the building's got to be maintained. In FPA 101, 2012, talks about continuous maintenance of fire resistance rated construction. The code's very clear, whether it's the NFPA 101 or the International Fire Code. Both of them say that the fire resistance rated construction shall be maintained, and then look at this, properly repaired, restored, replaced when damaged, altered, breached, or penetrated. It doesn't say do it once a year. It says restore it when damaged. That means as you go. So the building owner manager really should have some method that has the building management, the building engineer, monitoring what goes on in the building. How can that happen? A barrier management system, a barrier permit. If there's a service item being run in a building, before they pop open a ceiling tile, they meaning the subcontractor or even the in-house staff, then they have to get a permit from the building engineer located wherever in the building. That building engineer would have a checklist on that permit system that says you're penetrating fire resistance rated walls. We're going to have the Firestop contractor come in and fix those after you're done, or incorporate it as part of the project for that electrical contractor, communications contractor, or whatever. Very important, very, very important. So whether you're in Canada, Canada says the same thing. Shall be repaired so that the integrity of the fire separation is maintained. Important stuff. I want to get back to the questions, though. There's been several questions that have been asked along the way regarding the AHJ and other things. I'm going to make my little screen bigger, and then I've also got questions from the attendees. Those that the official presentation part's done, we've gotten our 2 hours in. Now it's time for the questions and answers. And give me a second here to take a look at one of these really long questions. Here's a question that says, if an element is added to a fire stopping system and adds to the integrity of the condition and doesn't take away from the assembly, would we say that this condition to the AHJ to give a judgment on? Okay, that's a really complex question. We saw in Chapter 1 the building official really has been given power by the code to do and make judgments about everything, all things. The building official can say whatever the building official feels is correct. But I'm sure that there's a code of ethics and there's a limitation to what the building official can and cannot do ethically, knowing that they don't have, may not have, the direct experience with fire testing of products or testing of products. Let's take the wind resistance, for instance. In hurricane areas, in order to test for a hurricane-proof window at FM approvals or UL, think of a pitching baseball batting cage with baseballs thrown through 2 tires that are spinning, thrown at you to do your batting practice. Take a 2x4 wood stud and run it through that baseball throwing machine at 80 miles an hour and throw it at the glass. If the building official sees a product that passes at 78 miles an hour instead of 80 miles an hour and makes a determination that that's okay, is that the right thing to do? Is it going to protect that building from the minimum requirements? Not sure. Hasn't passed the test at 80 miles an hour. Maybe we don't know if it's passed at 50 miles an hour. We just don't know. In the fire testing, how do we know that the engineering judgment will actually pass that fire test? If the building official makes the engineering judgment saying, oh, that's close enough, does the building official have the fire test knowledge to know how that exact chemical makeup of those products is going to perform in a fire? I don't have any idea how that's going to work. The manufacturer that did the chemistry probably doesn't have any idea how it'll work until they fire test it, unless they have systems that bracket the exact condition. Maybe the annular space is big on a plastic pipe, and they've got another plastic pipe assembly that simulates it that shows it might pass. The building official has the power to say, yeah, sure, I approve it. But does it make it safe? I'm not sure it makes it safe. I'm not sure that's the right thing for the building official to do. Will I ever say the building official can't do it? Nope, they have the right to do that. It's a big debate and something that's a really, really good question, and I appreciate you asking it. At some point, I'll have a conversation. We'll open up the conversation to our building official friends and let them talk about it too. Should the AHJ strictly adhere to the fire stop system at all times? My opinion is yes. If an element is added to the fire stop system that adds to the integrity of the condition, should the AHJ give it a judgment? We answered that. Next question, could we, let's see, add some light to section IBC 715. Is a tested joint system not required where a joint width is less than 0.062.5 per inch? Does it mean addition to max width, etc.? Great question. I'm going to use the International Building Code. Let me see if I can get over to the 2015 code. I think I've got sitting up here. Let's see now. Here we go. Actually, I got the 2012 code. I'm in Chapter 7. Let's go to Section 715, Joints. Okay. In general, joints installed in or between, and I'm going to make this bigger so we can see it, in or between fire resistance rated floors, floor ceiling assemblies, and roofs or roof ceiling assemblies shall be protected with an approved system. Take a look at this. Nowhere in this charging language does it say the size of the joint. Nowhere does it say the size of the joint. The concept that's in fire resistance rated construction is that the continuity has to be there. The question comes in is when somebody saw cuts in a concrete floor or wall, and that saw cut doesn't continuously go through. Does that need a fire stop? Well, looking at the intent of the code, the continuity of the fire resistance, has that been breached? I don't think so. I'd let the AHJ answer that question. I'd let the designer answer that question. Personally, I'd say it has not breached it if the continuity has not been breached. In 715, there's also a section that talks about control joints, the exceptions. And this is where you would see whether or not a joint has to be protected. So coming over to joints, here it is. Control joints not exceeding a maximum width of 0.0625 per inch. The way I interpret control joints is that they're not continuous through the wall or floor. The way others determine them is another story. Let's go to Chapter 2 and see what Chapter 2 says about control joints. Actually, I'm going to start with Chapter 7's definitions. I don't see any definition for a control joint in Chapter 7. Now let's go to Chapter 2. Chapter 2 of the International Building Code, scrolling down and looking for control joint. Let's see, I don't see a definition yet. Let's take a look. Control area. Nope, no definition for control joint. Most of the time a control joint is a saw cut that doesn't go continuously through the floor or the wall. And that's probably why in the building code in Chapter 715 it asks for the control joint to pass this test. and that test is the ASTM E119 UL263 test. Back to joints. Let's go back to the charging language for joints. Okay. So let me get back to 715. Sorry about the movement there. Looks like my code, there it goes. Okay, 715, joint systems. Control joints not exceeding a maximum width of 0.625 and tested in accordance with E119 and UL263. So if there's a control joint and someone says, I don't have to fire stop it because it meets this exception, that company has to now show a tested system to UL263 or ASTM E119 that shows that that 0.625-inch joint passes that test. So the exception is very clear that it can be done. So again, watch out for definitions. Watch out for the intent of the code, because the intent of the code asks for continuity of the fire resistance. Great question. Thank you. I'm going to look for a couple of more questions here. Start from the, let's see, where are the rest of them? Let's see. At a recent seminar I was speaking at, this is from somebody else, I was informed by a building official that they have the right to require special inspections on all fire stopping regardless of building type on the following section. Special cases, 1705.1, limited to the following examples, et cetera, et cetera. And the question is, materials and systems required to be installed in accordance with manufacturer's additional instructions that prescribe requirements not contained in the code or in the standard referenced by this, all fire stop systems. I'm not sure I understand the question, but here's the program. Back to Chapter 1, the building official can require more than what is required by the code if he or she feels that there is a risk that's required. That building official is given tons of power. Yes, they can do things. Yes, they can require. They can also make a determination that half-inch drywall mud's a fire stop. Is it responsible? Heck no. Is it something that could be brought through the political process to show that that building official may not be competent? Sure. Somebody could do that if they wanted to. Great question. Really appreciate you asking that. Secondly, EJ is being used for non-standard applications on perimeter edge of slab seals, and the installed condition does not reflect the EJ, and the safing material below the top seal is not effective, not installed per the system. This happens every project. Who's responsible for the non-conformance, especially when the system provided, no, this has happened and nothing, does nothing? Great question about ethics in the construction industry. The FCIA set up this UL Qualified Contractor Program and the FM 4991 Approved Contractor Program, plus the special inspection, to provide the check and balance to make sure the fire stopping gets installed right the first time, and then make sure the inspection takes place so that the special inspector, who hopefully has passed the FM and UL exam and the UL or the ICC exam when it shows up and exists. What we're trying to do as an association is build the knowledge level of everybody in the industry so they understand what is acceptable and what's not. I don't think that anybody can regulate against criminality. There are plenty of laws in all of our countries wherever we sit today. Those laws are conformed to by law-abiding citizens. How do you control the criminals? That's what all of us try to do. How do you control people that intentionally install stuff incorrectly or unintentionally do it, either for profit or by accident? That's what we're trying to do with these FM and UL programs in the ASTM E2174, 2393, the exams, the fire stop containment worker education programs. We're trying to find a way to minimize the amount of unethical things or craziness that takes place. Great question. Really appreciate you doing that. So next question. I'm going to scroll back up and see if I've hit them all. As soon as I've hit those, I'll get to the board. Let's see. Okay, I can't see that I've missed any of the questions. If I have, please type it in again. But what I'm going to do is organize all the people that have their questions, their question mark up. So if you want to ask a question at this point, put your question mark, press the question mark button, and then I'll open up the microphone so that you can speak from wherever you are. So if you have a question, if I didn't get to it, type it in, and I'll try to do that. The main webinar is finished, yes. We're just taking questions and answers now. But if you're still on the call, you'll get credit for 2 hours and 20 minutes, 17 minutes, 2 hours and 40 minutes if we stay on for another 45 minutes. So no problem there. So let's open up the microphone to those that have asked questions. And I'll go to the first one. It's all alphabetical, I believe. First one is Abdul Ghaffar Mohammed. Abdul Ghaffar, I've opened up the microphone for you to ask a question. Do you have a question, Abdul Ghaffar? Question, Abdul Ghaffar Mohammed. Okay, thank you. Alan Isberg. Alan Isberg, I'm going to open up the microphone for you. Alan Isberg, if you have a question, feel free to ask it. Okay. Next question is from Ariel Garcia-Ho. Ariel in Panama. Ariel Garcia-Ho, do you have a question?
No, thanks. I don't have any questions.
Okay, thank you, Ariel. Happy New Year to you and everyone else on the call. Arturs Gavrilovs. Arturs Gavrilovs.
Thank you.
Do you have a question, Arturs?
No, thank you.
Okay, thank you for being on the call. Crystal, H-E-G-E, Hedgie or Hedge-A. Crystal, do you have a question? I've opened up the microphone for Crystal. Crystal, any question? Moving on to the next one, thank you. Don Lindner. Don Lindner, I've opened up the microphone for your question. Don, do you have a question? Okay, can't hear Don. Next question, Gary Harsley. Gary Harsley, I've opened up the microphone. Do you have a question? Okay, not hearing anything from Gary. I'll turn off the microphone and move on to Gerard Carr. Gerard Carr, do you have a question? Okay, no question there. Next one is Greg Becker. Greg Becker, do you have a question? Okay, moving on to Helene Robertson. Holly Robinson, do you have a question, Holly? Okay, next question from Jason Cooper. Jason Cooper, do you have a question? Jason Cooper, I open up the microphone for you. Do you have a question, or are you okay?
I'm okay.
Thanks, Jason. Next question, Mark Fiji. Mark, do you have a question? Mark Fiji. Okay, nothing there. Scott Bergstrom, your question mark is up. Scott Bergstrom, do you have a question? Okay. I have some questions that came in on the question and answer thing. First one is, how long does it take a special inspection agency to get IAS accredited? That really depends on the inspection agency. And the critical thing is the agency gets the accreditation, the individual gets a certification. If you notice back in the special inspections chapter, it calls for 2 approvals by the authority having jurisdiction. The first one is the approved agency, and the second one is the special inspector. Now the question is, what's an approved agency? An agency is a company. What's a company? A company can be a sole proprietorship, a C corporation, sub-S corporation, small corporation, billion-dollar corporation. That's the agency. If it's a sole proprietor, it might be that the sole proprietor is the approved agency and then is also approved by the AHJ as the special inspector, because the special inspector is the qualified person. So there's 2 approvals needed. The approved agency can be the IAS AC 291 accredited special inspection agency, that special inspection agency by International Accreditation Services gets accredited to IAS AC 291. IAS AC 291 is the accreditation criteria for special inspection agencies. And if you remember the types of things that a management system has to have for the contractor program, you'll see that the similar types of things are needed in the inspection agency program. The special inspection agency has to have a management system. That management system can be managed by one person who's the special inspector. They just have to have policies and procedures they follow to get the quality done the way it was supposed to take place. Good question. How long does it take? Can take a company anywhere from a month and a half to 2.5 years to get accredited. It all depends on how good they are at running their management system. And FCIA in the members only section has a management system template built for those special inspection agencies and the approved contractors that'll help them get through that along the way. So great question. Really appreciate you asking that. Again, back up to the approvals needed by the AHJ. This is something that gets missed in the industry a lot, is this concept of approved agency and special inspector. Many AHJs think all they got to do is approve the special inspector. They need 2 approvals, but they can approve both at the same time and say it. That's what the code is asking for. Second, I have contractors who are FCIA members. Really glad to hear that. This is an AHJ asking, and not FM or UL approved. As an AHJ, we ask the contractor to submit a quality assurance manual or a management system manual in order to qualify them as a jurisdiction. What's our recommendation? Following a checklist to make sure they provide good quality assurance program without the benefit of them being covered on the management system program. Well, as an association, we don't mandate that the FCIA member has to be FM approved or UL qualified. They can have their own management system, and many of them do. They can use the FCIA template. The critical part is the audit by a third-party independent entity, FM or UL, that says that the company actually follows the procedures that they talk about in their management system manual. It's not that expensive to get done, and there are lots of these contractors all over the place. How expensive is it to get done? $6,500 bucks. If you're in Phoenix and you want to go to a Cardinals game, you're going to spend $250 bucks a ticket. There's $1,000. You're going to take 6 people to dinner. There's $2,500. That's $3,500 bucks of the whole program already spent on 1 football game. 2 football games, and you've built a management system and gotten your company UL qualified or FM approved, and you've proved to the building official and the architect and the general contractor that you've got better qualifications than the other guy. This has already started happening in the free enterprise system. There are areas where there are 5, 6, 7 FM or UL qualified contractors because the general contractor figured out that this is the way to qualify that these companies have the qualifications to get stuff done. Is FCIA membership alone a good thing? Absolutely. We really appreciate that. It's a great thing for the companies to do. Great question. Really appreciate it. Would the fire stopping exam by FM benefit a fire protection engineer? The question is absolutely. Fire resistance rated construction is something that's not taught in architectural and engineering school. If it is taught, there's an hour session on it. Yet sprinkler design is covered as a course of, I don't know how, could be a year, could be 2 years, I don't know. So I'm not a curriculum developer. We're offering to the fire protection engineering schools the ability to have a curriculum on fire resistance rated construction, already have. And we're working together to see if we can get that done. Next question that came in, other than healthcare, where do you see the inspection and continuing maintenance of fire stop systems trending in importance? As an association, we see it trending in all types of buildings. I live in Chicago area. The city of Chicago for high-rise buildings, which is another occupancy that we see it being importantly enforced. We saw the city of Chicago, because they've got a high-rise ordinance that gives the option to the building owner to not put in a sprinkler system. They use a life safety ordinance, and if they're able to prove that the building's safe through a number of checklist items, including alarms detection, fire resistance rated construction, compartmentation, fire doors, fire stopping, fire dampers, education of the occupants, all that kind of stuff, so that they don't have to retrofit in a sprinkler system in a high-rise building. We would like to see this kind of ongoing, continuing observation by the city continue. You're not going to believe this, but after sitting with the city, not just the city of Chicago, but lots of cities, many of the building officials who are doing the right thing and in their heart have the right thing in their intent, they have a very tough job, because building owners sometimes know politicians who say this building official is being crazy. He's asking me to fill the holes in the walls of fire resistance rated construction and make them work. And as a good building official, you're saying to yourself, well, duh, that's needed, and it's part of the building code. It's the minimum to get by. It's the law. But those are the things that the building official has to deal with. And God bless those people. They really work hard. They're very good people. They try their heart out, but they're influenced by lots of different things. We think that it's important to have, based on the fire code, and that fire code is very clear. And maybe what needs to happen is the building owner manager needs to wake up and see that there's a law that says that if they don't visually inspect annually and repair, restore, replace when damaged or breached, these two things, this is immediate stuff for their continuous fire resistance rated construction, cause property damage, they're going to get they're going to have some very big legal issues to deal with. Next question, does the UL stamp in plastic electrical boxes mean it doesn't need to be addressed even if it breaks the code for membrane penetrations? Oh boy, good question. Back to the continuity of fire resistance. The building code says where electrical boxes needed to be treated by fire resistive, fire resistive materials. There's a classification for it in the UL directory. There's a code requirement for it that talks about the separation of those boxes in membranes of the fire resistance rated assembly. That's where we need to pay attention to that. Good question. Next question is, if there's a difficulty in finding a third party to inspect, can the AHJ do the fire stopping inspections instead of a special inspection agency? Absolutely is the answer to that question. The AHJ can serve as a special inspector. Financing it would be another issue, though. How does that get paid for? Why would they want to do that would be the question on two fronts. One is the approved or qualified firestop contractors travel. Many of them cover several states and not just one city. In Chicago, for instance, the concrete contractors don't go very far, nor do the concrete trucks delivering it. It's because it's heavy and hard to transport. Firestop materials are typically very small, and it's a very knowledge-based industry, knowing the system selection, how to get the system selected and installed to the tested listed system, to the manufacturer's installation instructions and MSDS sheets and product data sheets. Those installation instructions are the barrier to entry. Transportation of heavy materials is not the barrier to entry. So really the difficulty is not that hard. These companies can travel. Companies that build healthcare facilities come from all over the place. In Chicago, we've got general contractors traveling in from Iowa 5.5 hours away performing work. Firestop contractors travel the same way. There are contractors in Wisconsin, 1.5 hours north of Chicago, performing work in Indianapolis 4.5 hours south of Chicago. The knowledge base travels. Hop on the FCIA.org member list and find a contractor that is close by. This member list has contractors that will travel. If you take a look at the FM 4991 approved contractors, there's a map of them, and as you can see, they cover the whole country. what we did was ask the contractors, what coverage areas do you have? All of them are everywhere. They'll also cover all the provinces as well. Looking at the geographic coverage, they are everywhere. Yeah, there's not too many of them in Montana, Idaho. Las Vegas had some, but these contractors travel all over the place to service fire stopping, and as FM and UL. Next question, can the AHJ obtain a FCI template to verify contractors following the template when trying to prove their qualifications? That's a good question. I'll have to answer that after talking to our accreditation committee. The template is something that gets edited. It's got minimum requirements in it, and frankly, rather than giving the AHJ the template, which is multiple pages long, it's probably better that the AHJ get the critical elements that should be in the management system of the contractor. Sorry about that. Let me get back to this again. Those critical elements that Firestop contractor or special inspection agency should have in their management system were up on the slide. And that slide has all of these different items. That's what you should pay attention to. Good question. Next question is, are floor T ratings a code requirement? I'm seeing Firestop specifications require floor penetratings, but most do not. Great question. Let's go back over to the International Building Code, Chapter 7. In 714 penetrations, the code says F and T rating, and it'll say that the T rating's got to be there except for a couple of areas. Let's see where that T rating is. T rating, temperature rating. Let's see. Rather than scroll around, I'll instead give you the exceptions. There's only one exception where the T rating is not required. That exception is in the same exception that you would find for fire stopping, and that's where concrete, grout, or mortar is used as a fire resistance rated assembly, tested as an assembly, or equivalent thickness is provided by the code. And the equivalent thicknesses you would find over here in section 722, the calculated fire resistance. So there's two ways to prove that the generic materials will work. One is tested to ASTM E119 or UL263, and no flame passes through. And the second one is using this prescriptive method that says maximum 6-inch nominal diameter penetrating item, opening area of 144 square inches, concrete, grout, and mortar permitted, full thickness of the wall, or the thickness required to maintain the fire resistance rating. The thickness required to maintain the fire resistance rating is down here in the equivalent thickness. This equivalent thickness, cast in place precast concrete walls, et cetera, 3.5 inches for an hour, 5 inches for 2 hours, depending on the aggregate. Lightweight aggregate gets you 3.6 inches for a 2-hour rated assembly. That's how you find that kind of stuff. Great question. Thank you very much. But the T rating is supposed to be, I believe the code reads, maintain the fire resistance rating with the T rating equal to the fire resistance rating of the assembly, unless the penetrating item occurs in a cavity or in a shaft. The cavity would be protected. The whole idea of the T rating is that fire doesn't spread from compartment to compartment by thermal conductivity of the penetrating item. So a metal pipe will heat up 325 degrees above ambient right away. Cardboard burns at, as we know, Fahrenheit 451, 450 plus degrees. When that penetrating item gets above that temperature, if there were things stored, boxes, combustible items next to that penetrating item, fire could spread because that box would catch on fire, of paper, box of whatever, and fire spreads without flame ever poking through. So the T rating is needed where penetrating items are exposed to things that will catch on fire. That's basically what the code says. So therefore, the T rating is required in certain areas. It's not required when it's in between the cavity. So don't forget about that. Let's see. Next questions. Someone's looking at the FCIA website. Can you take the UL Firestop exam somewhere else other than an FCIA, such as proctored sites? Yes, there are 3 other sites currently. The 3 other sites are the UL locations. Underwriters Laboratories will be in February 12th up in Toronto. We'll be in Melville, New York in March. We'll be in Chicago sometime this summer. And then we'll be at all of the FCIA symposiums. We'll do one in Ottawa, Canada. We'll do one in Abu Dhabi. Do one in Doha, Abu Dhabi in the UAE, Doha in Qatar. So off we go. Getting back to the questions, I think that covers the questions that were there. Let me get back to the people that were asking questions and open up the microphone. Sonia Antunovic-Kursik. Sonia, do you have a question also? Okay. Next person with a question with a hand up, Todd Gilbert. Todd, do you have a question? Okay, nothing from Todd. Next is from Felix Candejas. Felix, do you have a question?
Hello, how you doing?
Doing okay, Felix.
I have a quick question. Now, penetration's going from the bottom of the concrete, like ceiling assembly. I get a lot of cast iron pipe going up from that, and most of it's not fireproof, and some of it goes through walls where I can't see if it's fireproofed or not. Would it be advisable just for us to fire stop it and just be safe on that part?
Good question. Let me see if I can catch that. So the question is, let me make sure I understand the question right. It seems a membrane penetration where a metal pipe is going into a concrete assembly. It may be going into a wall assembly cavity. It may be turning inside that floor assembly, going elsewhere, and then coming out somewhere else. Can't find where that top side is. What should we do? If it's existing construction, so Felix, did I get the question right? Okay, so I think I got the question right. So here's the answer to that. In new construction, it's easy because things are not covered up on the floor above. In existing buildings, that gets quite difficult. In existing buildings, maybe it is advisable, and the fire protection engineer, the design professional, would have to make that call, saying, where should we fire stop these assemblies? But if it's a membrane penetration, it would need a membrane penetration fire stop system. There are membrane penetration fire stop systems that are offered by the manufacturers in the directories. Ask the manufacturers, they'll tell you what a one-sided system can look like. That fire stop system would have to be taken care of where it goes into the assembly and then wherever it comes out. So then you'd have to find where that pipe is, find the other side of it, and do the other side, because the membrane is both sides. You don't know whether the fire is going to start upstairs or downstairs. So good question. Appreciate you asking it. A very good one along the way, too. Another question came in. When a rated wall assembly terminates at a non-rated roof ceiling, is a fire-resistant joint required to maintain the continuity of the wall assembly? Wow, that's a great one. That's really a good question, and I'm available afterwards if you want to have a discussion. Of course, I'm going to have to go to the take a break in between 15 minutes or so before I'm back on the telephones. Certainly feel free to give me a phone call to talk about that. I'd be happy to cover that. So here's the answer to the roof ceiling fire-resistant joint system. The code is, it depends on how clear and how it's interpreted. Let's go back to 715 joints. 715 joints has sections that cover fire resistance rated construction. In the general section, it talks about in or between fire resistance rated walls, floors, floor ceiling assemblies, and roofs, or roof ceiling assemblies. It's got this fire resistant rated in between all of it. Shall be protected for the period, not blah, 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 blah. And then they talks about how they should be tested. There's several exceptions: floors, atriums, floors within malls, floors and ramps in open parking garages, mezzanines, walls that are permitted to have openings, roofs where openings are permitted, control joints. There's one other section, though, that talks about a similar area that you're talking about, the curtain wall assembly. The curtain wall assembly has a fire-rated floor hitting a non-fire-rated curtain wall. And the code says that the fire-rated floor has to be continuous, outside wall to outside wall, floor ceiling assembly to floor ceiling assembly. If you use that logic, even though the code doesn't specifically say non-rated fire resistance, non-rated roof assembly, it would be safe to say, at least in my opinion, I'd leave it up to each AHJ, because each AHJ is going to make their own decision about this particular area. If the continuity of the wall has to be to the assembly where it stops, then it would have to be fire stopped to extend the rating of that fire resistant rated wall up to that non-rated assembly. There is a test standard at ASTM. ASTM, I believe, it's either E230837 or 2738, I don't remember the number, that shows testing of fire-rated walls to a non-rated roof assembly. There's not many tested systems, but there are some. This occurs at smoke barriers a lot, especially at single-story medical office buildings and healthcare facilities. Smoke barriers exist, 1-hour fire-rated assemblies, and then the smoke barrier, if you go back to smoke barrier and look at the definition of what it's supposed to be in the general section, here it is under continuity. Smoke barrier shall form an effective membrane continuous from outside wall to outside wall from top of the foundation. Look at all the continuity here. This is telling you that if it's a smoke barrier and you're hitting a non-rated assembly, extend the wall up to the non-rated assembly. Put a fire stop in to do that. So in my opinion, it's a use a fire stop system to do that because you're extending the fire rating in the floor of the wall. Let's see what the continuity says about fire barriers too. Fire barriers probably has that exact same continuity requirement. Where the heck is it? Yep, continuity. Here we go, 707.5. Here it is again. Top of foundation of floor or wall assembly to the underside of the roof sheathing. So that tells you fire barrier, non-rated or rated, touching a non-rated or rated, fire stop. My opinion, again, I'm not the AHJ. You got to talk to the AHJ in every community to know that. So don't rely on me and say, well, Bill said it's okay. This is really the AHJ's call. And this is where the discussion is about sometimes clear and unclear code requirements, because it doesn't exactly point out that says, okay, if you have this, do that. Those that look at the code, though, say there's a continuity requirement and that fire rating's got to extend all the way up and all the way out. That's awesome. Thank you for the question. Have you seen where a fire stop installer uses a through penetration system for a membrane penetration with the manufacturer letter included? That's a great question, and thanks for asking it. There's currently a discussion about membrane penetrations and whether a through penetration can be used for a membrane penetration. The membrane penetration, think about the fire dynamics. The systems show a through penetration in, let's say, a fire-rated wall assembly. In that wall assembly, we don't know if, and I'm going to go backwards and try to do a different system. Let's do a WL. There's WL. Let's do 1049. WL 1049. And let's take a look at it pictorially so you can see what the point is. Okay. 1049 is a metal pipe. This metal pipe just went inside the wall, and now it takes a right-hand turn and goes down the wall. That metal pipe is inside this wall membrane. In order to get a 2-hour fire rating, you need both membranes, both of these fire-rated gypsum wall assemblies. This first wall membrane is a sacrificial lamb. It's gone at the end of 2 hours when the hose stream test hits it. I don't know what its thermal transmission rate is, nor the temperature inside this cavity after the end of the fire test. If this metal pipe is turning down, and it's at 600 degrees, 1,000 degrees, it may drive the moisture out of the gypsum wall, or if it's a concrete block wall, the concrete block is also relying on the matrix of the moisture, cement, and aggregate matrix to maintain its fire rating. So as soon as this metal pipe turns down and goes into the wall assembly, it changes the fire dynamics of that wall. So a manufacturer letter is great, but I'd like the manufacturer to, I mean, this is something that question should be asked. Was there a test that proved that the second membrane actually worked in the wall assembly or the floor assembly? Has it been tested to show that that didn't degrade the other side of the membrane? If yes, okay, let's go. Sounds great. Good question. Thank you very much. Let's get down to a few of the other questioners. Let's see, other questions. I got Eric Carrion's got his hand up. Eric, do you have a question? I know you've been asking on the typed in. Okay, I'm not hearing you there. Louise Schlatter. Louise, you've got your hand up and a question. Louise, do you have a question? Okay. Rick Tinsley. Rick Tinsley, you have a hand up and a question. Rick, do you have a question? Okay. Wayne Jewell. Wayne, I can't open the microphone, Wayne. I apologize. For some reason, it's not letting me. Saifuddin Tahir over there in UAE. Saifuddin, do you have a question?
Yes, I did put that question and you have nicely answered it. Thank you very much. And it was how long it takes to get the special inspection agency or an individual get accredited requirement AC291. You did answer my question.
Thank you, Saifuddin, and Happy New Year to all our friends in the United Arab Emirates, in the Middle East, in Doha. Really appreciate that you guys can make these calls. Okay, at this time I see the questions have stopped. I think I've covered them all, and really appreciate the number of questions that we get throughout these webinars. It's as much fun for me to get them and try to answer them and challenging, I hope, as it is for you as attendees. So at this point, what I'd like to do is, if anybody else has a question, type it in quickly and I'll answer it. If not, I'll wrap up our session and say if you're not a member of the Firestop Contractors International Association, please join us. Membership is, yes, it costs money, but it provides the opportunity to offer these free webinars. Really appreciate that. And really appreciate everyone spending their time on the phone with us today and on the webinar. I'll put this webinar, I and our staff will put the webinar up online sometime this afternoon. And again, if you have personal questions that we didn't answer on the call, feel free to call me at the phone number on your screen. I'll be in all day today. I got another webinar, teleconference that starts at 1:30 Central Time, Central Standard Time. And I'll be unavailable for about an hour. Otherwise, I'm in all day today, in all day tomorrow. And yes, we work late until sometimes 9 o'clock p.m. in the evening. So if it's the Middle East and 6 a.m., we might be here. Thank you, everyone, for spending time with us today. Look for a certificate in the next 30 days that says you attended the webinar that you can use to self-report to the various agencies. Have a great day, everyone. And we'll look forward to seeing you next time. Thank you.